Hello everyone, how are you all doing? I hope your exam prep is going well. Now, since your exam is approaching very near, you all might be tensed, right? What to prepare, what to focus on, what concepts are more important, and what questions to solve. So, to cover you all with that, we have brought you with 50 most important questions in mathematics. So, this will help you understand what concepts to focus on and what all concepts you require for your exam, and these are based on all the patterns of your previous year, and this will help you understand what to focus on and what to aim for. So without wasting any time, let us begin with our first question. So our first question is from set theory, and what it says is, for a set S and T, we have defined the difference of sets which we know definition, and let PQR be three distinct sets, then we have to tell which of the following is correct, right? So this is a very easy question. We'll approach this question with examples. We'll take particular example and we'll discard the option. That is the best, easiest way to do a question if we can discard the options with the help of an example. So for this particular question, what we can take, let set P is equals to 1 comma 2, Q is equals to 2 comma 3, and set R to be singleton 2. So we have taken this particular example to discard some options. So let's look at first option number A. So option A says P union Q minus P is equal to Q. So if we calculate this particular thing, what it will be? Q minus P. So first Q minus P. Q minus P. So we'll delete all elements in Q which are also in P. So we're left with only 3, and then we have to take P union Q minus P. So we'll take the union of this with P. That will come out to be 1, 2 and 3. But our Q set was only 2 and 3. So these both are not equal. Hence, option A is incorrect. So for option number B, we'll look at that later on, right? For option number C, let's come first. It says P union Q minus R is equal to P union Q minus P union R. So Q minus R, first let's calculate that for this same example. Q minus R, that will be 3. Right? And then we have to take its union with P. So P union Q minus R. So we'll take the union of this with P. That will give us 1, 2, 3. And now let's calculate the right hand side, which is P union Q minus P union R. So first let's see what is P union Q. So what is a P union Q? P union Q. That will give us 1, 2, 3, and P union R. P union with R. That will give us 1, 2. So what we get? This implies P union Q minus P union R. That will be what? Singleton 3. Will delete the elements which are in this and also this. So the only element left is 3. So are these two equal? No. So option C is again incorrect. For option D, let's take same P and same Q, and let us take a different value of R. So let R is equal to singleton 1. Okay. So this satisfies this condition. R is a subset of P. So R is a subset of P. Now let's calculate the left hand sides. What it says? P intersection R union Q minus R. So let us first look at this term. This is Q minus R. Let us calculate it here. So Q minus R. So what that will be? Q minus R. There are no element in common. So Q minus R will be nothing but 2, 3, right? And then we have to take its union with R. So we'll take the union with R, which is 1. So that will give us R union Q minus R. That will be what? 1, 2, 3, right? And then we have to take its intersection with P. So intersection with P will give us what? 1, 2. So P intersection R union Q minus R. That comes out to be what? 1, 2. But what is our P intersection Q? So P is this and Q is this. So P intersection Q, what will be the only element there? Only 2. So but P intersection Q is equals to singleton 2. So these two sets are not equal. Hence option D is incorrect. So the only option left is B, which has to be correct, and let us look at why that is correct. So for B, option B, what it says, if R is a subset of Q, then P intersection R union Q minus R is equal to P intersection Q. So R is a subset of Q. Let us look at its Venn diagram. So this is something, let's say Q, R is its subset. So R will lie completely inside it. So this is R. So we have what? R is a subset of Q. Then we have to calculate R union Q minus R first, and that's its intersection with P. So R union Q minus R. So this will be Q minus R. This is Q minus R. And then if we take R union Q minus R again, so what we will get? We'll again get our set Q. We'll take this portion and its union with R. So what we will get? Our complete set Q. So this is nothing but Q. And we have to take its intersection with P. So P intersection Q is what we get in our left hand side. And what does our right hand side says? It also says P intersection Q. So hence option B is correct. I hope you get this question. So let's move on to the next question. So what does our next question says? Let A be a set from 1 to 10 and B is equal to m by n, where m comma n belongs to set A, m is less than n, and GCD of mn is 1. So we have to tell number of elements in set B. So this is basically a counting question and also some set theory. Along with that, GCD problem. So let us look at this manually. So for m is equal to 1. So if you put m1, so all the elements n has to be greater than 1. So n can be from 2 to 10, right? And other condition says GCD of m comma n should be 1. So for this particular m1, if I take any value of n from here, GCD will also be 1 for any value. So how many total values we get? From here, total 9, right? For every M1, we can take 1, 2, 1, 3, 1, 4 till 1, 10. So we have 9 values from here. Similarly, for M is equal to 2, N should be greater than M. So N should belong to 3 to 10 and GCD of M comma N should be equal to 1. So for M is equals to 2, its GCD with 3 is 1, with 4 it is not, then 5. So what will be our N values? So N will be equal to 3, 5, 7 and 9. So these are the values of N for which this M satisfies this condition, and this is also true, and GCD is also 1. So from here how many total? 4. 9 then 4. Similarly for M is equals to 3. What will be our N? N will be 4, 5, 7, 8 and 10. So how many total values we will get? 5. So from here 5. Similarly, if we calculate for M is equal to 4, so N will be 5, 7 and 9. So 3 values. Then again M is equals to 5, we get 6, 7, 8 and 9. 4 values. So I hope you can all check this N satisfies this condition as well, and GCD of M comma N should be 1. So for M is equal to 6, N will be what? 7, just one value we get 7. So 1. Now for M is equal to 7, we get N to be 8, 9 and 10. So 3 values, then M is equal to 8. We get N is equal to 9. 1 value, and last M is equal to 9. So N is equal to 10. How many value again? 1. So we have to tell what? Number of elements in set B. So we have to just what? Add all these values, because that will what? Make the all the elements which belong to this set. For M1 we have all this, for M2 we have these values, then for 3 these values and so on. So we have to just add these. What will be the addition of all these terms? 1, 2, 5, 6, 10, 13, 18, 22 and 9, 31. So the answer is 31. So now let's look at our next question, which is a mix from set theory quadratic equation, and along with that you need to know the properties of exponential and logarithm. So what it says, e की power 5 log ex square plus 3 is equal to x की power 8, and we have to tell the product of all the solution, and x should be greater than 0, right? So taking ln on both sides, so we'll take natural logarithm on both the side of this equation. So what we'll get? Ln e की power 5 log ex का square plus 3 is equal to ln x की power 8. Now ln and e 1 and anything in the power comes in front. So it will become 5 log ex square plus 3 is equal to 8 ln x. And we know log base e and ln are the same thing. So we can write this as 5 ln x square plus 3 is equal to 8 ln x, which implies, what this implies is 5 ln x square minus 8 ln x plus 3 is equal to 0. Right? This is what we get. Now what we do is we let ln x is equal to t. So we will let ln x to be t. Then what we get is 5 t square minus 8t plus 3 is equal to 0. So this is what we get, and this is a quadratic equation. Now we have to tell the product of all the solutions. So if this has solution, let's say t1 and t2, right? Then we know sum of solution is t1 plus t2 is minus b by a. For quadratic of the form, ax square plus bx plus c is equal to 0, right? So this is t1 plus t2. So for this, what will be it? 8 by 5. Now if I put this value here, what I'll get is ln of some x1 is equal to t1 and ln of some x2 is equal to t2, right? So let's just add these two. So ln x1 plus ln x2 is equal to t1 plus t2, right? So t1 plus t2, from here it is 8 by 5. So ln x1 plus is equal to 8 by 5, and from the log properties we know ln of a plus ln b is equal to ln of a into b, which is 8 by 5. So this implies x1 into x2 will come out to be e to the power 8 by 5. So the product of all the solution is e to the power 8 by 5, which is our option A. I hope this question is clear to you all. So the next question, it says A, B, C be distinct real numbers such that a square plus b is equal to b square plus c is equal to c square plus a. Then we have to tell the value of a plus b plus c and c plus a. So this is just taking it on the left side and manipulating and then computing the value of a plus b plus c and c plus a. So let's take this equation and this first. So what it is? A square plus b is equal to b square plus c. So taking b square term on the left, a square minus b square is c minus b. This implies a plus b and a minus b is equal to c minus b. I hope this much is clear to all. Now from here we need a plus b. So what we'll do, we'll just take it on the left and divide it. A plus b is equal to c minus b upon a minus b. Let's say this to be our first equation, right? Similarly, we can take b square minus c square is equals to a minus c, which will give b plus c, and b minus c is equal to a minus c. So from here b plus c will come out to be a minus c upon b minus c. Let's say this is our second equation, and let's calculate our third as well. So what that will give us? A square minus c square is equals to a minus c. We are comparing this equation with this equation. So a square minus c square is equals to a minus c. Then again that will be a minus b, right? Because here it is a square plus b is equal to c square plus b. So it will be a square minus c square is equal to a minus b. So a plus c, a minus c is equal to a minus b, and from here a minus c will be a plus c will be a plus b upon a minus c. So what we need to do? We just need to multiply all these three terms. So let's do that. What it will give us? C minus b upon a minus b into a minus c upon b minus c and a minus b upon a minus c. Since we need to calculate this value a plus b, b plus c and c plus a, and from here we get these value to be equal to this, and hence we'll calculate this. So from here a minus c cancels out, a minus b cancels out, and if we take a negative sign common here, it will give us minus b minus c, and the denominator is b minus c. So cancel, and hence ultimately we get minus 1. And why we were able to cancel all these terms from numerator and denominator? Because it said a, b and c are distinct real numbers. So a was not equal to c and a was not equal to b. Hence cancellation was possible. So the answer is option A, minus 1. So the next question, this is from again quadratic equation, and we need to tell set of all possible values of a for which the roots of this equation are alpha and beta, such that alpha and beta is between 1, right? So let us analyze how this will look in graphical terms. So if we take hint from the graph for this, so it says alpha and somewhere 1 and then beta. So alpha and beta are the roots of this equation, right? And since the coefficient of the quadratic term, which is x square term, is positive, so coefficient is positive. What this implies? This implies it is an upward opening parabola. So how will that look like? So this quadratic will look like this, right? So from here what we can say, the value of this at 1, that lies below the x-axis, so the value will always be negative. So what we can conclude from here, the value of this particular expression, which I denoted by f. So basically the value of x square plus 2x ax plus 3a plus 10 at point 1, it will be less than 0, right? Where I have taken fx to be our expression, right? So we'll just compute it at 1. So what it will be? 1 square plus 2a plus 3a plus 10. So this value should be less than 0, and that gives us 5a plus 11 less than 0, which gives us 5a should be less than minus 11 and a should be less than minus 11 by 5. So from here we get a condition on a that a should be less than minus 11 by 5, right? And on real line, how it looks like, this is the point minus 11 by 5. So value of a should be less than minus 11 by 5, which means all the values less than minus 11 by 5. So what this set will look like, this is minus infinity to minus 11 by 5. So from here we can clearly see this is our option number B. Hence the set of all possible values of a is from minus infinity to minus 11 by 5. So next question says a and b be non-zero real numbers. We have given a general polynomial x ki power n plus cn minus 1 x ki power n minus 1 and dot 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 c naught, where these are integers. N is greater than or equal to 3, and we have to tell which of the following statement is correct. So we'll again solve this question with the help of examples and discard all the options which are not possible, right? So what does first says, if this is a root of px, then n must be even. So here the restriction what it says is n must be even. So if we take n to be odd and show this type of root exists, then option A will be false, right? So we can take for option A, let px is equal to x square plus 1 and x minus 1. So we take a polynomial, this is of this form, coefficient of highest power will be 1 if you multiply this, and then all the coefficients will be integers. So this satisfies the condition, n is greater than or equal to 3. But if we look at it, what are its roots? Roots will be plus minus I, right? Which are complex, and hence n is not even, n come out to be odd. Hence option A is false. For B, if A is a root, then n must be odd. So we can construct a polynomial, a very easy polynomial, let's say x plus 1, x minus 1, x plus 2, x minus 2. So this, while opening, the coefficient will be 1 for the highest power and all other coefficients will be integers if we multiply all the integral terms, right? So, and the power will be 4, 1, 2, 3, 4 factors. So n is even and all the roots are of this form. So n can be even as well. So B option is false. For option C, it says if a plus ib is the root of this, then a plus ib whole square can never be the root. So let's take our simplest polynomial px, which is x cube minus 1. So we all know for this, it is nothing but cube roots of unity which are 1 and we call omega and omega square. So roots are 1, omega and omega square. The roots, the cube roots of unity which we calculate, right? And we call them 1 omega and omega square. So here this is a complex number of the form a plus ib and its square, which is also a root of this polynomial. Hence option C is again false. Let's look at our option number D, what it says. If a is a rational root of px, then a must be an integer. So here it says it is a rational root, then it should be an integer. So we know for rational roots, we have a result. So for rational root of the form. So how rational roots will look like? The rational root will be of the form p by q, and q will be non-zero. So for rational roots of a polynomial with integer coefficient, so we have p must divide c naught. So p must divide the constant term part, and q should divide. So let's say here it is Cn. So Cn is basically what? The coefficient of the highest power, which is x ki power n. So for in particular case here, Cn is 1. So for our example, this implies q should divide 1, since the coefficient is 1 for x ki power n. So which implies what? Q can be either plus 1 or minus 1, because the only number that can divide 1 is either 1 or minus 1. So q has to be plus minus 1. And since if q is plus minus 1 and if we put it here, this implies p upon plus minus 1. And if we divide any number with 1 or minus 1, we'll be left with only the numerator part with a negative sign or positive sign, and p is since an integer. So if it has a rational root, then it must be integer, which is correct statement here. So option D is true. So the next question is from complex number. This question might look complicated, but when you will see its solution, it will be very easy for you to see that. So what it says is 1 plus z ki power 15 is a naught plus a1z plus dot 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 a15 z ki power 15. And what we need to calculate the value of a naught minus 4a2 plus 16a2 dot 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 2 ki power 14 a14 square and the square of this term. So what we can look from here is the terms are repeating after 2 steps, and this is 4, then next is 16. So powers are increasing in an order of 2. So first it was 2, then power was raised to again a higher power of 2, then again 2 ki cube, then 2 ki power 4, and so on till 2 ki power 15, right? And since these are coming in consecutive terms, so if we take, let z is equals to 2i. If we take the value of z to be 2i and put it here, what we will get? A naught as it is a1 into 2i, then a2 2i square, and what will be 2i square, which is 4i square, and I square is 1, so that will be minus 4, and that will be multiplied with a2. So from this and this, we just had to guess that we had to let z to be 2i in this expression. So if we substitute it here, what we will get? So this will become 1 plus 2i ki power 15 is equal to a naught plus 2i into a1 minus 4 a2. Then next term will be again plus, sorry, that will be minus 8i a3 plus so on. So if we substitute the value of z to be 2i, this is what our expression look like. And if we take this and write this in a complex number form, which is z is equals to x plus iota y form, so what it will be? A naught minus 4a2 plus 16 a4 plus dot 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 minus 2 ki power 14 a 14 plus iota is taken common and then it will be 2a1, then next it will be 8a3 and so on till it become this expression, right? So this is how we just took iota common and brought real terms together and imaginary terms together. So now we have to calculate the value of square of this term plus square of this term. So we know for z is equals to x plus iy. If we take mod z, that will be what? Under root x square plus y square. So if we take mod z square, that comes out to be x square plus y square. So this expression is x, this is complete y. So we can write it to be x plus I and this whole expression to be y. So we have to calculate the square of this plus square of this. So from this formula, what we need to do is just take the mod and square. So this expression was equal to this. So what we can do is 1 plus 2i mod of this whole square, that will be equal to x square plus y square, and x square plus y square is nothing but our complete expression, the value which we need. So what is 1 plus 2i mod? That will be under root 1 square plus 2 square and the power 15 and 2, that will become 30, right? So this is nothing but root 5 to the power 30, and which we can write to be as 5 to the power 15. So the whole expression value comes out to be 5 to the power 15. So from the options, that is option number D. So the next question is again from complex number, and what it says, let z1, z2, z3 be complex number which satisfies this complete constraint, and then we have to evaluate the quantity log 2 16z1 plus 4z2 and 4z3 mod, right? So let's look at all this expression one by one and solve it step by step. So first it is given 4 is equal to 4z1. We know property of complex number, mod z square is what? Z1 into z conjugate, right? What it is? Mod z square is equal to z into z conjugate. So we'll take square of this 16, that will come out to be 4z1 and 4z1 whole conjugate. Now since 4 is a real number, we can take it out from the conjugate part. This will become 16 is equal to 16 z1 into z1 conjugate. 16 cancels out. This become z1 is equal to 1. So from here, what we can say, 1 upon z1 is nothing but z1 conjugate. Let's say this to be equation first. Similarly, the next it says 4 is equal to z2 minus pi, and applying the same property that is mentioned there, what we will get, 16 is equal to z2 minus pi, z2 minus pi whole conjugate. And since the expression here says what, 4 upon z2 minus pi, so we'll take 4 common here and we can write this as 4 upon z2 minus pi. So z2 minus pi comes in the denominator and we just took a 4, and that will be equal to Z2 minus pi conjugate upon 4. So we can write it this way, right? 4 we can take multiply here like this, 4 into 4, and then 4 upon this and this upon 4. So this is our second expression. Similarly, we can take the third one, that will give us what? 4 is equal to Z3 plus pi. This implies 16 is equal to Z3 plus pi into Z3 plus pi conjugate, and that will give us what? 4 upon Z3 plus pi is equal to, that will be equal to what? Z3 plus pi conjugate upon 4. So this is the three expressions that we got. Now we'll substitute the value of first, second and third in this particular case expression. So that will give us what? 4 is equal to mod. Here we'll put Z1 conjugate. So Z1 conjugate plus Z2 minus pi conjugate upon 4 plus Z3 plus pi conjugate upon 4, and that was in inverse, right? So let's just calculate this and solve it. So what it will be equal to? So if we take the LCM, that will give us what? 4 is equal to 4Z1 conjugate plus. Now since pi is a real number, so we can remove the conjugate from pi, and that will become Z2 conjugate minus 4 plus Z3 conjugate, Z2 conjugate minus pi and Z3 conjugate plus pi whole upon 4, and with this inverse, right? This is what the expression will become. Now pi and pi cancels out. So the expression what we are left with is 4 is equal to 4 Z1 conjugate plus Z2 conjugate plus Z3 conjugate upon 4 inverse. Now since this is a mod of some complex number, which is this, right? And mod is just a value, so we have to take its inverse, so we can just reciprocate the terms. So that will give us 4 is equal to 4 upon 4Z1 conjugate plus Z2 conjugate plus Z3 conjugate, right? And the inverse will go off. And since 4 is a mod value itself, so it will get out and 4 and 4 will cancel out, and what we get is modulus value of 4Z1 conjugate plus Z2 conjugate plus Z3 conjugate is 1. Now since this is the value of conjugate and that is mod is equal to 1, so from here we can say 4Z1 plus Z2 plus Z3 mod will also come out to be 1, because modulus of a conjugate of a number and the number is same, so which will be 1, right? And what we had to calculate was, we had the expression log base 2 16Z1 plus 4Z2 plus 4Z3. So that will come out to be what? We can take 4 common, log base 2, we take 4 common, and 4 can be taken outside the mod as well. So 4, this will be 4 z1 plus z2 plus z3. So this we evaluate it to be 1. So this will become what? Log 2 4 into 1, which is nothing but log with base 2 and 4. And what is the value of log base to 4? We can write 4 as 2 ki power 2, then 2 will come in front and log 2 and 2 is 1. So this will be 2. So this is our final answer. So which option? Option number A. So value of this quantity came out to be nothing but 2. Now in the next question, we have to tell the least value of this trigonometric expression. So this is a question from trigonometry, and let's look and solve it step by step. So what it says is, the expression given to us is cos square theta minus 6 sin theta cos theta plus 3 sin square theta plus 2. So this is what we are given. So you need to remember two trigonometric expression for this. One is what? 2 sin theta cos theta, which is equals to sin 2 theta, and the second one is 2 sin square theta is equal to 1 minus cos 2 theta. So we will use these two identities. These are general identities which we have studied in your class 11. So from here we can write this as cos square theta plus sin square theta. Since this was 3 sin square theta, we took 1 sin square theta. Then this term can be written as, from this identity, minus 3 sin 2 theta. And we are left with 2 sin square theta plus 2. Now we know cos square theta plus sin square theta is 1. So 1 plus 2. That will become 3. This is 3 sin 2 theta. And from here we know 2 sin square theta is 1 minus cos 2 theta. So that will be what? Plus, it was minus, no, that was plus only, 1 minus cos 2 theta. So ultimately this becomes 4 minus, I am taking common, 3 sin 2 theta plus cos 2 theta. So we have to tell the least value of this expression. And this is what? An expression of the form. This is expression of the form A sin x plus B cos x. So we can see this is of the form A sin x plus B cos x. What is the least and maximum value for this? We know the range of this is minus under root A square plus B square and under root A square plus B square. So this is the range of this type of expression. So if we substitute the value of A and B from here, that is 3 and 1. So that will be, for this, it will be minus under root 3 square is 9 and 3 square plus 1 square, which will be nothing but minus under root 10 to under root 10. So this is the range of this expression, minus root 10 to 10. And we have 4 minus this term. So what it will be? The final range will be 4 minus root 10 to 4 plus root 10. So the value of this expression will always be in this interval. So what is the least value which we can see from here is 4 minus root 10. So the least value of this expression is 4 minus root 10, which is option number C. So all you needed to know was the trigonometric identities here and this particular expression range, how it looks like. So what does the next question says? Let ABCD be a trapezium where AB is parallel to CD and AB is perpendicular to BC. So suppose the length of side AB and CD are given to us and we are given coordinates of B and C, which are 2, 5 and 3, 7 respectively. Now E is a point on side BC and AE plus D is such that it is minimum. Then we have to tell the coordinate of E. So let us draw it first, how this figure looks like. So let's say this is our point A, this is B, C and D, right? This is a trapezium and since AB was given perpendicular to BC, so this is a 90-degree angle, and since these both are parallel, this angle will also be 90-degree, right? Now this is 3 units, this is 5 units, and what we are given? And we are given coordinates of B and C. So the coordinate of B is 2, 5 and coordinate of C is 3, 7. Now what is the extra information? E is a point on BC. So we have taken any point E on BC and such that AE plus DE. So AE plus D. So this length is given to us to be minimum. Then we have to tell the coordinate of point E, right? So we know by reflection principle, if the length is minimum, then if we take the reflection about any point, then that is what gives us the minimum length. So we can take reflection of point D along the line BC. So we will consider BC as a mirror and we will take the reflection of this point D in its side. So let's call this point to be D dash. So we have taken this point to be D dash and this is nothing but reflection of point D along this BC. So we will join this and then join this. So this is minimum when this is a reflection of point D. We could have taken reflection of point A as well. That would have made us a figure and that would have given a triangle in the below format, right? So since this was 5 centimeter and reflection is preserving length, so this length is also 5, right? So CD dash is also 5. Now we look at these two triangles ABE and CD dash E. Consider triangle which is a triangle A, B, E and triangle D dash C, E. So when we look at these two triangles, this angle is 90 degree, this angle is 90 degree. This angle and this angle, they form a vertically opposite angle, hence they are equal. So by A criteria which we have for our similar triangles, we can say these two triangles are similar. So angle B is equal to angle C and angle E is equal to angle E. This is vertically opposite and these are 90 degree each. So we can say these two triangles are similar. Triangle ABE is similar to triangle D dash CE. So now since these are similar triangles, we can compare the side ratios. So what the side ratios will say? AB upon D dash C must be equal to BE upon CE. Now since AB was 3 and CD dash was 5, so this will be 3 upon 5. That will be equal to 3 by 5. So we know the ratio of this side, which is 3:5. So now we have to tell the coordinate of point E, and if we look at this line, this is sectioning this line, this is breaking this line into segment internally, bisecting this line internally. So in the ratio 3:5. So what we can use? Section formula here. We can look at this figure as this way. So this is our point B, this is our point C, and we have known the coordinate of this 2, 5, and the coordinate of this is 3 and 7. There is a point E which internally divides this in the ratio 3:5. So using the section formula, we can calculate the coordinate of point E. So let me do it here. So we will apply the section formula for x coordinate of E. Let's call this x comma y. Okay. So what will be our x coordinate? This into this plus 5 into 2 upon 3 plus 5, which is 8. So what it will be? 9 plus 10, 19 by 8. And what would be our y coordinate? That would be 3 into 7, 7 3s are 21, plus 5 into 5, 5 5s are 25, upon 8 again. So that would be 46 by 8. So looking at the option, our option number C is correct. So this is the solution and answer of this question. Let's move on to our next question. What this says, suppose A, B are such that these 3 points in the coordinate plane are distinct, collinear, and the line passing through these points is not parallel to y-axis. So we are given properties of this point. They all are distinct, collinear. Collinear means they lie on the same line and the line passing through them is not parallel to y-axis. Then for all choices of A and B, we have to tell the slope of the points. So we have to tell how many values slope can take for such 3 points. Now since these all 3 points lie on a line, so we can take the slope formula between 2 points. So what would be our slope? M is equal to, for 2 points, let's take this and this first. So what it will be? B square minus B upon A square minus A. And similarly for these 2 points, it will be what? A cube, that would be B cube minus B square upon A cube minus A square, right? So taking these two equal, what we get? B common, B minus 1 upon A common, A minus 1. That will give us, taking B square common here, B minus 1 upon A square, A minus 1. So this is what we get. Now taking this on the left hand side. So what we get is B by A, B minus 1 upon A minus 1 minus B square by A square, B minus 1 upon A minus 1 is equal to 0. Now since B minus 1 upon A minus 1 is common in both, so we can take this as B minus 1 upon a minus 1 and b by a is also common, and from here we will be left with 1 and this minus b by a. This is equal to 0. So what we did, we just factorized this and wrote in the factorized form. So b minus 1 upon a minus 1 we have taken common from both, b by a common, and this is what we get. Now since three numbers multiplied and giving us equal to 0, so either one of them has to be 0. So let's take case by case. First, if b minus 1 upon a minus 1 is equal to 0. So first we have considered this part to be equal to 0. So denominator, since denominator can never be 0, so what this will give? This implies b minus 1 is equals to 0. This implies b is equal to 1. So the value of b will be 1. So what kind of points we will get from here? A comma 1. This implies points are a comma 1, a square comma 1 and a cube comma 1. So the points will be a comma 1, a square comma 1 and a cube comma 1. Now here the value of a cannot be 0 or 1. Why? Because then the points will not be distinct. Since the points are said to be distinct, so value of a and a square and a cube cannot be equal, because then the points will be equal. So value of a cannot be 0 or 1. So from here, if we look at the line, what kind of line it will look like? Since y is fixed at 1, so y value will always be 1, and this is how this line will look like. So what is the slope of this line? The slope of this line is m is equal to 0. So that is what the slope of this line is, a horizontal line with slope 0. So one value of m is equal to 0, right? So let us consider our next case. So what will be our next case? If b by a is equals to 0. So if b by a is equals to 0, this directly implies b is equal to 0. And then how the points will look like? Points are a comma 0, a square comma 0 and a cube comma 0. Now again value of a cannot be 0 or 1 because of the same reason we gave here. So this is what? A line on the x-axis, and again the slope will be, this is nothing but, this is if our coordinate axis, so this would be our line, right? With slope again m is equal to 0. So the slope value here is also 0. Now let us look our third case. So what does our third case says? Third is 1 minus b by a is equals to 0. If 1 minus b by a is equal to 0, then b by a is equal to 1, which implies b is equal to a. So b is equal to a means the points will look like what? A comma a square comma a square and a cube comma a cube. So how this line will look like? This is a line which looks like this, y is equals to x type, right? So what is the slope of this line? The slope will be m is equal to 1. So how many values of slope we get? 1, 0, for second case also 0, and from the third case we got 1. So we have exactly two values of the slope if all these conditions are satisfied. So let's move on to our next question, which says the locus of center of circle which touches the circles this and this externally. So we have to tell the locus of center of a circle which is touching these two circles externally. So let us first look at these two circles and draw them and look like how this external circle look like. So first circle is x square plus y square is equals to a square. So this center is 0, 0 and radius is a. So for this circle center is this, and for this circle if we manipulate it we can write it like x minus 2a whole square plus y square is equal to 4a square, right? So what we did, we took this on the left side and we added and subtracted 4a square on both sides, and this is what the equation looks like. So what its center and radius would be? So with center 2a comma 0 and the radius would be here 2a. So we have two circles, one with center 0, 0 and radius a, and another circle with center 2a comma 0 and radius 2a. So let's roughly look at how these circles look like. So let's say this is our first circle, center at 0, 0 and radius a, and the second circle is with center 2a comma 0. So let's say somewhere this point is 2a comma 0, and now since the radius of this circle is 2a, so the length of this part is 2a, so the circle would have looked like somewhat this, right? So this is how the second circle looks like with radius 2a. Now we are given there is another circle which just touches these two circles externally. So there is a circle which is touching these two circles at 2 points. So let the center of this circle be at coordinate x comma y, right? So we have to find the locus of the center of this circle. Now if I join center of these two circles and this. Now since these circles are touching each other externally, from here to this point the length is 2a and let's say the radius of this circle is r. So this will be 2a plus r, and this part, this much is a and this is r. So what it would give us? This and this part is a plus r. Let's name these first. So let this point be, let's say C dash, and let's say this is O. So what we know, CO is equal to A plus R and C dash O is equal to 2A plus R. So this is the distance of this, and by distance formula we also know what would be CO, x square x minus 0 whole square plus y minus 0 whole square in under root, and similarly for this the distance formula if we apply. So this is equals to under root x minus 0 square plus y minus 0 square, and this would be equal to under root x minus 2a square plus y minus 0 square. So these are two equations that we got. We will just do what? We will just subtract. So C dash O minus CO will be what? This minus this. R cancels out. 2a minus a is a, right? From here that will give us equal to under root x minus 2a square plus y square minus under root x square plus y square. So ultimately we got a is equal to this minus this term. So we'll take this on the left hand side with a. So a plus under root x square plus y square is equal to under root x minus 2a square plus y square. So now we'll just do squaring and solve this. So squaring both sides. So after squaring, what we got? A square plus x square plus y square plus 2a under root x square plus y square is equal to x minus 2a square plus y square. So after squaring, this is what we got, right? Now again solving this square term a minus b ka whole square, that will give us what? This is equal to x square plus 4a square minus 4xa plus y square. So this is equal to this, right? So now cancelling terms, x square cancels out, y square cancels out, and what else we have? 4a square and a square. So we'll take it to the right and that will become 3a square. So ultimately what we are left with? So what we have is 2a under root x square plus y square. So 2a under root x square plus y square is equal to, this we have taken to the right, 3a square, and what we are left with here is minus 4xa or 4ax. Now since a is the radius, it cannot be equal to 0. So we have a here as well and we can take a common here. So we can cancel a from both the sides. So this implies 2 under root x square plus y square is equal to 3a minus 4x. Now we'll do squaring again and we'll solve this. So this implies 4 x square plus y square is equal to 9a square plus 16 x square minus 24a x, right? So this is 4x square and this is 16x square. We'll subtract that taking on the right hand side. So that will become what? 12 x square minus 4 y square minus 24 ax plus 9a square is equal to 0, right? So we have to make it from one of these forms. What does the first form says? 12x minus a ka whole square. So if we substitute it here and try to make it of this form, we can take 12 common. This is x minus a square minus a square. So this will give 12x square and then 12a square. So we have 9a square here, but we want 12a square. So what we'll do, we'll add 3a square. So 3a square adding here and here as well. So equal to that will give us 3a square, which we have in this first expression, right? And what else it will give? 12 to 24, 24xa, which we already have, minus 24xa. And the last term that is left is minus 4y square. So we can manipulate and write it in this form. So this form is similar to form in option number A. So what is the answer of this? 12x minus a square minus 4y square is equal to 3a square. I hope you understood this question. Let's move on to our next question. What does it say? Let A be the focus of parabola y square is equal to 8x. And the line intersect this parabola at 2 points. We call them B and C. Now, if the centroid of triangle ABC is given to be 7 by 3 and 4 by 3. So, we are given coordinates of centroid of this triangle. Then we have to calculate the value of BC square. So, let's again draw this figure first and look at it with the help of its figure. So, this is a parabola of this form, y square is equal to 8x. So, if we compare with the general parabola equation, which is y square is equals to 4x, from here after comparing we get a is equal to 2. So, the value of a is 2. So, the focus of parabola is at 2, 0, because the coordinate of focus is a, 0, right? So, focus is 2, 0. So, this is somewhere, let's say the point 2, 0. That's where the focus lies and its vertex is at 0, 0. So, this is somewhat the graph of this equation, y square is equal to 8x, and now the line y is equals to mx plus c intersect this parabola at 2 points B and C. So, let us draw a line and intersect it at 2 points. So, let this be the line which is intersecting at point B and C. So, let's call this point as B and let's call this point as C. Now, if centroid of the triangle ABC, what is our point A? Point A is the focus. So, this is the point A. Now, we are given this triangle and we are said that the centroid of this triangle has coordinate 7 by 3, 4 by 3, right? So, in parametric form, we can write the points of parabolas, right? We can write any point that lie on a parabola in its parametric form. So, what this B point can be written as, we can write it as 2 t1 square, 4 t1. So, the x coordinate can be written as 2 t1 square, and if we put it here, 8 into 2 t1 square, that will give us 16 t1 square, and this is equal to what? Y square. So, y square is equals to 16 t1 square, and if we take square root both sides, that will give us 4 t1. So, y coordinate will come out to be 4 t1. Similarly, for this, we can take it to be 2 t2 square, 4 t2. So, we can take the parametric form of these 2 points, and A already we know it is 2, 0. Now, what is the formula for centroid? The coordinates of centroid is x coordinate x1 plus x2 plus x3 by 3. So, all the coordinates divided by 3. So, what that will give? 2 plus 2 t1 square plus 2 t2 square by 3, and what would be its y coordinate? y1 plus y2 plus y3 by 3. What it will be? 0 plus 4 t1 plus 4 t2 upon 3, and this is given to be as equal to 7 by 3, 4 by 3. So, we will just compare them. What we will get? 3 and 3 cancels out. We get 2 t1 square plus 2 t2 square is equal to 5. So 2 taking common, so t1 square plus t2 square will be 5 by 2. So this is what we got as first equation. Now for y coordinates, what we'll get? 4 t1 plus 4 t2 by 3 is equal to 4 by 3. Then 3 cancels. We did same for here. 3 cancels out. 2 subtracted from that side, that gives us 5. So 4 common. So t1 plus t2 will come out to be 1. Right? Now what we have to calculate? The value of BC square. So we have to calculate the length square of BC. So B is here and C is here. So what is BC square? BC square will be x1 minus x2 square plus y1 minus y2 square. So that will be 2 t1 square minus 2 t2 square whole square plus 4 t1 minus 4 t2 whole square. That is what we know, distance by distance formula, and taking the square. So root cancels from both sides. So this is from our distance formula, taking 2 common and then square also. So this will be 4 t1 square minus t2 square whole square plus 4 common and then squaring. So 16 t1 minus t2 whole square. Now this is a square minus b square. So what we can write it as? t1 plus t2, and we had a square as well, so squaring, and t1 minus t2 square plus 16 t1 minus t2 square. So from here we know we want value of t1 plus t2 and t1 minus t2. So we have this and this. So from here we know formulas for the squares. So what does our square formula says? If we take t1 plus t2 whole square, what is it? t1 square plus t2 square plus 2 t1 into t2. So this is its value. t1 plus t2 is 1. So 1 square is equal to t1 square plus t2 square is 5 by 2. So this is complete 5 by 2, and this is 2 t1 into t2. So if we take it to the left, we'll get what? 1 minus 5 by 2, which is minus 3 by 2. So minus 3 by 2 is equal to 2 t1 into t2. So from here we get t1 into t2 is equal to minus 3 by 4. So we calculated the value of t1 into t2, right? But we want what? We want t1 plus t2 and t1 minus t2. t1 plus t2 we already have, but we need t1 minus t2. So for that, what we know? t1 minus t2 whole square is equal to t1 plus t2 square minus 4 t1 into t2. These are simple algebraic formulas which we know from our class 10th as well. So I hope you know all this. So what is it? t1 minus t2 square. What is a t1 plus t2? 1. So 1 square is 1, and then value of t1 into t2 minus 4 into minus 3 by 4. Right? So 4 and 4 cancels out, minus minus plus. So 1 plus 3. That will be 4. So T1 minus T2 square is equal to 4. Since we need directly the value of squares, we don't need to calculate the value of T1 minus T2 by taking square root, right? So what we can put here now is 4, T1 plus T2 is 1, so 1 square into 4 square plus 16 into, sorry, we don't need to take the square because it is already T1 minus T2 square. So this is only 4, right? So what it will be? 4, 4, 16 and 16, 4, 6 4 the 24, 2, 64 plus 16. So 64 plus 16, that will be equal to 80. So this is what? 64 plus 16, which is equal to 80. So the value of BC square is 80. So what we got? The value of BC square came out to be 80. So which is the option, correct option? Option number A. So let's move on to our next question, which is from our conic section and more importantly from ellipse. So what it says, ellipse has its center at 1 comma minus 2, its focus is at 3 comma minus 2 and one of its vertex is at 5 comma minus 2. So we have to tell the length of its latest rectum. So here we only need to directly apply the formulas once we know how this ellipse looks like. So let's draw this ellipse. Now its center is at 1 comma minus 2. So let's consider this point to be 1 comma minus 2, right? So its focus is at 3 comma minus 2. So that will be somewhere here, 3 comma minus 2, and its one of its vertex is at 5 comma minus 2. So this will be 5 comma minus 2. So we have taken minus 2 as this line. So these are 3 points. So this is its center and this is one of its vertex. So the ellipse would have looked like this. Since this is center and this is focus and this is one of its vertex, let's say it's V. Now we know center to focus and center to vertex. So this is nothing but value of A from center to vertex. That is the same. So that is the semi-major axis, center to vertex. So its length is 5 minus 1. So value of A will be what? 5 minus 1, which is 4. And we also know from center to focus, it is A into E, right? Value of semi-major axis into eccentricity. So AE is equal to what is its length? 3 minus 1, which is 2. So we know value of A, which is 4, and we know value of A, which is 2. Now for ellipse which has x-axis as its major axis, we know B square is equal to A square minus AE square. So what will be A square? 16 minus AE square is 4. So the value of B square is 12. So we know value of A, value of AE and B square, right? This implies what? Value of A square will be 16. Now what we all need to calculate is just length of its latest rectum. So the length of latest rectum is what? Two B square by A, that is a formula for length of latest rectum, which is what? 2 into 12 upon A is 4. So what is the answer? Length of its latest rectum is 6. So correct option is option A. This was a very easy question. All you need to do was calculate the value of A and then AE. Now let us look at this question carefully what it says. For some theta in 0 comma pi by 2, eccentricity of hyperbola which is in this form is root 5 times eccentricity of ellipse which is given by this equation. Then again we have to tell the length of lattice rectum of the ellipse. So first let us convert this both equation in its standard form. So for hyperbola, the equation would look like x square by 10 minus y square by 10 cos square theta is equal to 1. So this is how we can write this equation in standard form. Now we want eccentricity. So what is the formula for eccentricity of hyperbola? It is under root 1 plus b square by a square. So if we calculate this, what it will come out to be 1 plus 10 cos square theta upon 10. This is our b square and this is our a square. So 10 and 10 cancels out. This is under root 1 plus cos square theta. Now let us look at our ellipse. So for ellipse, what it says, x square sec square theta plus y square by 5. So standard form will be x square by 5 cos square theta plus y square by 5 is equal to 1. Now for ellipse, we know the formula for eccentricity is what? Under root 1 minus semi-major x square upon, minor x square upon major x square, right? So we want minor x's and major x's for this. That depends on which is our major x coordinate or y coordinate. Now let us look at this carefully. What it says, 5 cos square theta, and theta is from 0 to pi by 2. So cos square theta will always be less than 1 and it will always be greater than 0. So 5 cos square theta will always be less than 5. So the major axis lie on the y-axis part. So this ellipse is like this. Since cos square theta is always 0 to 1, it will always lie between this value. So 5 cos square theta will always be less than 5. So this is what makes our major axis. So this is what ellipse looks like. So its eccentricity would be under root 1 minus. This is our minor axis. So this will be 5 cos square theta upon 5. So 5 and 5 cancels out. So this gives us under root 1 minus cos square theta. Let's call this to be eccentricity of ellipse and this to be eccentricity of hyperbola, right? And we are given eccentricity of hyperbola is 5 times, root 5 times the eccentricity of ellipse. So when we compare this, what we get is under root 1 plus cos square theta is root 5 times under root 1 minus cos square theta. So since all the terms are in root, we can take square on both sides. That will give us 1 plus cos square theta is equal to 5 1 minus cos square theta, right? So if we open this, what we get? 6 cos square theta would be equal to 4. This will give us minus 5 cos square theta. We took it to the left. That became 6 cos square theta and 5 minus 1 is equal to 4. So from here, we can say cos square theta will be what? 2 by 3. So the value of cos square theta is 2 by 3. And we have to calculate what? Length of the latest rectum of ellipse. So again, length of latest rectum, what it will be? 2 into minor axis. Minor is what? Our x coordinate one. So 2 into a square, which is 5 cos square theta upon b, which is root 5. So the formula is 2 a square by b. So regardless of what is a or b, what we take is 2 minor x square upon major axis. So 2 into 5 cos square theta upon root 5, and cos square theta value what is it? Is 2 by 3. So we'll substitute it here. That will give us 2 into root 5, and 5 will become root 5, and cos square theta is what? 2 by 3 into 2 by 3. That will give us 4 root 5 by 3. So final calculations gives us 4 root 5 by 3, which is our option number D. So the length of latest rectum of ellipse is 4 root 5 by 3. Now this question is from our permutation and combination. What it says, number of arrangements of letter research such that either of the word starts with R or it ends with H. So we have to find all the letters, number of arrangements of this letter such that it either starts with R or ends with H. So this is a combination of this plus our set theory. So it says R or H. So we'll calculate what? So we want number of letters starting with R union number of letters ending with H. So we'll calculate number of letters starting with R plus number of letters ending with H minus number of letters starting with R and ending with H. So why did we do that? Because in doing this, we double counted the letters starting with R as well as ending with H. So we subtract this. This is a general formula from our set theory as well. Hope you know all that. So we'll first calculate number of letters starting with R. So letters starting with R. Starting with R. So R is fixed at first place. So what? How many terms we have? 1, 2, 3, 4, 5, 6, 7, 8. So R is fixed. So we want to fill this 7 places with letters what? E, S, E, A, R, C, H. So we have to fill this position with letters from this terms, right? So we can see E repeats twice and none of the letter is repeating. So the formula for this of arrangement of n number of letters which are repeating n number of times, some of them are repeating n number of times, is what? Total upon repeating. So this will be 7 factorial upon 2 factorial. So these are letters starting with R. And if we calculate this, this comes out to be 2520. Right? We can calculate this and it will be 2520. Now letters. So now we want ending with H. So now the letters numbers which are ending with H. So H is fixed. So we are left with R, E, S, E, A, R, C. These are all the available words which we have, available letters which we have. Now here R repeats 2 times, E also repeats 2 times. So the formula will be 7 factorial upon 2 factorial into 2 factorial. If we calculate this, that comes out to be 1, 2, 6, 0. So this will be 1, 2, 6, 0. Now we want, starting with R and ending with H. Now since all the letters which were ending with H were included here as well, and all the letters which were starting with R will come here as well. So we have double counted this. So we will subtract all which are starting with R and ending with H. So R is fixed and H is fixed. So we have to fill 6 positions with the letters. What are the remaining letters? E, S, E, A, R, C. So now we have 6 letters in which E repeat 2 times. So the total number of arrangement will be 6 factorial upon 2 factorial, which is 6 factorial is 720 upon 2. Which comes out to be 360. So we just add these two and subtract this from this. So what we will get is, adding these two, this gives us 3780 and then subtracting 360. So the final answer is 3420, which is option number B. So the total number of arrangements of this letter is 3420. So what our next question says here now? It says sum of all the 4-digit number that can be formed using this digit. This is again a counting question as well as permutation and combination. So we have to tell sum of all 4-digit number that can be formed using the digits. So we have digit 1, 2, 2 and 3. So digits 1, 2, 2, 3. So let us first look at how many total numbers will be formed. So total numbers would be, what we need to do, we just need to arrange this 4 and 2 is repeating twice. So 4 factorial upon 2 factorial. That will be the total number of arrangement, this 3 numbers, and that will be what? 12. So we have total 12 4-digit numbers, right? So we wanted to fill 4 places with these digits in which 2 was repeating twice. So that comes out to be 12. Now it is a 4-digit number. So let's say it is A, B, C, D. At units place we have D, then ones place C, hundreds place B, and then thousands place B. This is how a 4-digit number looks like. So in expanded form we can write it as 1000A plus 100B plus 10C plus D. So this is how its expanded form looks like. Now let us fix one particular number at units place. So let's fix 1 at units place. So how many places are left to be filled? 3 places, and we have 2, 2 and 3. So 2 repeats twice. So number of arrangement will be 3 factorial upon 2 factorial. That will give us what? 3. So number of digits having 1 at its units place will be 3. So 3 numbers are such that its units place is 1. Then with unit place 2. So we have fixed 2 at the unit place and we want all the numbers which have this possible arrangement. So how many numbers we got for 1? 3, right? And this can fill any position. Now we have fixed 2 at the units place. So how many numbers we can get? We want arrangement of 1, 2 and 3. Since 1, 2 is already fixed, 3 different numbers, 3 possible arrangement. So that is what? Simply 3 factorial, which is 6. So numbers which are ending with 2 or having 2 at its units place are 6. So we have 6 numbers. So this is what these 6 number would have looked like with 2 at its units place fixed. Then again with 3 we will get 3 numbers. Why? Because we want arrangement of these 3 numbers in 1, 2 and 2, and 2 was repeating. So this will again be 3 factorial by 2 factorial, which gives us 3. Right? So numbers which are ending with 3 or having 3 at its units place will be 3. So what we did was we fixed the units place. Now if we look at the sum of all this, what it will be? 3 plus 5, 7, 9, 11, 13, 15, 15 plus 3, 18, 21 and 24. So sum of all these digits comes out to be 24, and we want what? Sum of all 4-digit number. So in this particular pattern, we fixed the numbers at units place. Similarly, if we do that for tens place, hundreds place and thousands place, sum of all the numbers at their particular places will be what? Always 24. So the sum is always 24. So we have to calculate the sum of all 4-digit number. So since we want sum of all 4-digit number, we can take what? Sum of all numbers at the hundreds place plus at thousand place, then at 100, then at tens place, and this is nothing but sum of ones place digits, right? So which the sum is always 24. So this will be what? 1000 into 24 plus 100 into 24 plus 10 into 24 plus 24. That gives us what? 24000 plus 2400 plus 240 plus 24. If we add all these, what we get? 4, 6, 6, 6, 2. So this is sum of all 4-digit numbers that can be formed using the digits 1, 2, 2 and 3. That comes out to be 26664. So from our option number A, 26664. So the next question is from our topic probability. So what it says is, consider 3 bias coins. Let probability of getting head be 1 by 3 and getting tail be 2 by 3. So this is not a fair coin, right? So the probability is 1 by 3 and 2 by 3. Now consider the experiment of tossing 3 coins. So we are tossing 3 coins one by one, and we are asked to have this following events. So E is the event at least 2 heads shows up. F is the event first coin shows tail. We have to tell the conditional probability of E given that F has already occurred. So we want conditional probability E, F has already occurred. Let's look at the events that will come under E first. So what the events will be? At least 2 heads. So at least we want 2 heads. So 2 heads or 3 heads will be the what that will come under this event. So at least 2 heads. Head, head, tail, head, tail, head, tail, head, head, and head, head, head. These are all the events that will fall under E. And the F says first coin shows tails. So the first coin should always show tail. So tail, head, head, tail head tail, tail tail head, and tail tail tail. So these are the possible events that will fall under this particular categories, right? So we want what? We want conditional probability of E given F. So we want P E given F. So what is the formula? Probability of E intersection F upon probability of F. Now event E intersection F, what all comes in intersection? Tail head head, tail head head. So nothing else is in the intersection. So we only have one event, which is tail head head, tail head head. So probability of intersection will be probability of tail head head, and we want probability of F. So first coin shows tail. So what is the probability of getting a tail? 2 by 3. So this will be 2 by 3 into probability of head is 1 by 3. So 1 by 3 upon 1 by 3 divided by, we want all the probabilities of these events. So tail headed first is 2 by 3 into 1 by 3 into 1 by 3 plus tail head tail. So 2 by 3, 1 by 3 and 2 by 3 plus tail tail head. So 2 by 3 into 2 by 3 into 1 by 3 plus tail tail tail, which is 2 by 3 into 2 by 3 into 2 by 3. So this is what we need to calculate. Numerators give us 2 by 27 whole upon 2, 2 to 4, 2 to 4, 2 to 8. So 8 plus 4 plus 4, 16, 16 plus 2, 18, and denominator is common for all these, which is 27. So 27, 27 cancels out, and we are left with 2 by 18, which is nothing but 1 by 9. So what is our answer? 1 by 9. So again, option A is the correct answer. So the next question is from our set theory mixed with probability. So in an office, 30% employees have scooter, 25% have car. Among those who have scooter, 90% do not have cars. So what we are told is, there is an office in which 30% students, 30% employees have scooters and 25% have car. And among those who have scooter, 90% do not have car. So we need to first look at this information carefully. So whenever there is percentage in any question and you want to use the set theory, we take it to be 100% so that it comes easily. So let total employees be 100. So we are taking total employees to be 100. Why? Because in percentage that is easy to calculate. Now only 30% of the employees have scooters. So number of employees with scooter will be, number of employees with scooter will be 30. Number of employees with car is 25. Now what the additional information says, among those who have scooters, 90% do not have car. So among all those who have scooters, 90% do not have car. What we can interpret from that? We can see only 10% of those who have scooter also have car, right? So what will be the 10% of 30? So 10% of 30 is 3. So we can say only 3 employees have both scooter as well as car. So this is what this information tells us. So employees with scooter as well as car, which we represent by intersection, is 3. because only 10% of the people who have scooter will have car. We can take 90% is 10% that will have car. So 3 employees will have car. So if we draw its Venn diagram, how that will look like? Let's say this is scooter, this is employees with car. These are total employees represented by universal set U, and intersection have 3 employees. So the common region will have 3. Total with scooter was 30. So this whole region represent 30. Now 3 already were included. So we are left with 27. And then with car we have 22. So this is how its Venn diagram look like. Now we want what probability that employee has car given that does not have scooter. So we want probability car given that does not have scooter, and it is given that does not have scooter, which we represent by scooter complement, S complement. So that will be probability C intersection S complement upon probability of S complement. So from Venn diagram, let us look at what these values will be. C intersection S complement. So C intersection S complement. So we want people who are having car but they should not have scooter. We want to have S complement intersection. So that would be this. So that would be what? 22. Also we know S intersection S complement is nothing but, sorry, C intersection S complement is nothing but SC minus S. So we can subtract C, we can subtract set S from set C. So C minus S would give us 22 and then S complement. So how many are there in S? 30, and we want S complement, right? So there are 30. So outside S, since we consider total to be 100 employees, so since S is 30 employees, so outside 30, 100 minus 30 would be 70, right? So there are 70 employees who are outside this portion. So this is 22 by 70, which is 11 by 35. So our answer is option number A. I hope you understood this part, how we calculated C intersection S complement and S complement. Let me tell you again for a better explanation or clarity. So this was C intersection S complement. So we wanted all those who were outside S intersection with C. So that would have given us this portion only. And there are 22 employees. And then we wanted S complement. So all those employees who do not have scooters. So there were 100 employees and 30 had scooters. So not having scooter would be 70. So 22 upon 70, and after cancellation that gives us 11 by 35. So the next question says there are 10 black balls in a box. Person picks 5 from box, paint them as white and then put them back again. So person now picks 5 balls from the box at random, and we have to tell that there are exactly 3 of them to be as white. So this is just a normal counting question with probability. So we have to tell exactly 3 of them has to be what? White. So 5C3. So these are total number of ways in which from 5 balls 3 can be white, right? And then remaining can be black. So 2 balls will be black, so 5C2. And how many total outcomes? He picked 5 balls from 10 balls. So 10C 5. So this is what we just need to calculate in this question. 5C3 is 10, 5C2 is also 10, and this would be what? 10 factorial upon 5 factorial into 5 factorial. So numerators 100 upon. This can be written as 10 into 9 into 8 into 7 into 6, 5 factorial upon 5 factorial into 5 factorial. So 5 factorial cancels out. This 5 factorial goes in the numerator. It becomes 100 into 5 factorial upon 10 into 9 into 8 into 7 into 6. So 10, 100 cancels. 5 factorial can be written as 5 into 4 into 3 into 2 into 1, and the denominator is 9 into 8 into 7 into 6. So 3, 2, 6 cancels out. What else we can cut? 4, 1, 4, 2, and there is nothing that can be cancelled, I guess. Then this is 50 upon, oh, we can cancel this as well. So that will be what? 25 upon 63. So which is our correct option? Option number C, 25 by 63. So this was a very simple and easy question. So let us look at our next question, which says we have to find the value of NC0 plus 2 into NC1 plus dot 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 n plus 1 NCN, where NC denote the number of combination of n objects taken k at a time, which is nothing but our binomial coefficient. So if we look at the common term, what it is? NC0 plus 2 NC1 plus dot 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 n plus 1 NCN. So we can write it as R plus 1 into NCR, and this R runs from R is equal to 0 to N. So we can write this summation in this format, R plus 1 NCR. Now we can take these two separately. That will be what? Summation R into NCR plus summation NCR. R goes from 0 to N, R goes from 0 to N. So this is nothing but sum of all binomial coefficients for this expression. So 1 plus x ki power n is what? NC R x ki power R, right? So if we put x is equal to 1, this is what this is. So if we put x is equal to 1, this is nothing but, if we take x is equal to 1, this is summation R running from 0 to N NCR. So this term is what? 2 to the power n, right? So this term is 2 to the power n. If you put x is equal to 1 in this, what we are left with to calculate? This part. Now we know this result, R into NCR is equal to what? N into n minus 1 C R minus 1. So if we substitute this here, what we get is sum from R is equal to 1 to n minus 1 C R minus 1. And here we have n also in multiplication. Since summation does not have any n, so we can take n to be common outside. So this term is nothing but this, and then taking summation, this is what we get. right? Now this is again sum of all binomial coefficient, but it is from n minus 1. So what we can do, we can take here n minus 1. So that will be what? 2 to the power n minus 1. So instead of running n, we took it from n minus 1. So this would be nothing but n into 2 to the power n minus 1. So the overall sum that comes out to be 2 to the power n plus n into 2 की power n minus 1. So from here, what is our correct option? Option number C. So this question is again from binomial theorem. So what it says, we have to tell the number of integral terms in this expansion. So the general term of this expansion looks like, so the general term of the expansion is NCR 7 to the power 1 by 8 power r into 5 to the power 1 by 2 n minus r. So this is what the general expansion of this looks like. And what is n here? N is 1016. So let's substitute the value of n. 1016 CR 7 to the power 1 by 8 into 5 by 1 by 2 to the power 1016 minus r. So this is what the general term of this expansion looks like. We have to tell the number of integral term. Since this is always an integer value, so for this to be a complete integral value, this whole power must be an integer and this whole power must be an integer. So all the terms will be integer. So what is our requirement? R by 8 must be an integer, and this is what 1016 minus r by 2, and 1016 minus r by 2 must be an integer. Also, since total terms were, power was 1016, so r ranges from, so r is from 0 to 1016. So this is the requirement that we want to fulfill. So for r by 8 to be an integer, r must be a multiple of 8. This implies r is multiple of 8. From here, what we can say, for this term to be an integer, the numerator part, this term must be divisible by 2, and for this to be divisible by 2, r should be a even number. So r should be an even number for this to be divisible by 2. Why? Because if r is odd, then even minus odd would give us an odd number which won't be divisible by 2. So for that, r, this implies r must be a multiple of 2, right? So since r is a multiple of 2 and r must be a multiple of 8, so from this condition will already be satisfied. So what we will calculate, we will only calculate all the values of r that are multiples of 8. So first value will be what? 0, next 8, and so on. So this r should be less than or equal to 1016. So let's see if 1016 is divisible by 8 or not. So what it will give? 1, 2, 7. So what gives? It gives 127. So this is perfectly divisible by 8. So what would be a last term? Last term will be 1016. So we can say r will take all these values. So what is this? These are multiples of 8. This is forming an AP with first term 0 and last term 1016. So we'll use the formula for AP and we will find out the total number of terms. So what is AP, AN is equals to A plus N minus 1 into D. What is our A? 0 plus N we don't know. Common difference of these terms is 8 and that is equal to 1016. So 0 is nothing. So 8 divide, we get 127. So this gives N minus 1 is equal to 127 and the value of N comes out to be 128. So value of N is 128. Option number D. So the next question is from our relations. It says R1 and R2 be two equivalence relation on a set S. Then we have to comment about the relation R1 union R2 on the same set S. We have to tell which of the following will it satisfies, right? So we have to check its reflexivity, symmetric and transitivity. So first let's look at reflexivity. For reflexive, right? Now since this is what R1 union R2, now for any x comma x that is in a relation R1, x comma x will go into the relation R1 union R2 as well, since that is in R1, right? Similarly, for any x comma x in R2, this will imply what? X comma x is in R1 union R2 and this also implies x comma x is in our R1 union R2. So whenever we have x comma x kind of element in our first relation, that is also present in our R1 union R2, and if it is in R2 then it is also in R1 union R2. So from here we can say R1 union R2 is reflexive. Now let's check symmetry. So symmetry, right? Suppose we have x comma y is in our R1 union R2. So we have an element x comma y which is in R1 union R2. So what we need to show? We will show y comma x is also in R1 union R2. So if this is in R1 union R2, what this implies? This is either in R1 or that is the definition of a union. Either it has to be in R1 or it has to be in R2. But we are already given R1 and R2 are equivalence relation. So this implies y comma x is in R1 or y comma x is in R2. Now if y comma x will be in R1, that will go in union, and if y comma x is in R2, that will also go in union. So this implies y comma x is in R1 union R2. So this is reflexive as well and this is symmetric as well. What we need to check is about transitivity. So this is not a transitive relation. Let's take an example and show that. Let S is equal to 1 comma 2. We define a relation R1 on this set as 1 comma 1, 2 comma 2, 3 comma 3, 1 2 and 2 1. So we have taken a relation on this set of this format. You can easily check this is an equivalence relation on this set. Similarly, if we take R2 as 1 comma 1, 2 comma 2, 3 comma 3, 2 comma 1, 3 comma 1 and 1 comma 3. This will also form an, let's take it 2 comma 3 and 3 comma 2. So this will also form an equivalence relation on this set. Now if we take union of these two, So what will be our R1 union R2? 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 3, 2, and 2, 1. Now this is what R1 union R2 looks like. Now here we have 1, 2 and 2, 3. So this A, this is B, then again B and C. So A, B is in this, B, C is in this, but for transitivity, A, C must also be in this. But we don't have 1, 3. But 1, 3 does not belong to R1 union R2. And hence, this is not a transitive relation. So it is reflexive and symmetric, but not necessarily transitive. So correct option is option D. The next question says M to be the set of all 2 by 2 matrices with integer entries, and we are defining a function from matrices to matrices which is given by this, and we have to comment on whether this is injective or surjective or not. So let's quickly look at this and we'll discard this using examples. So for injective, so for injective, if we say two elements are mapping to same image, then we are done with that, right? So let's take matrix I, which is our identity matrix. So what would be our f of I? Fi is I square, and we know for identity matrix, square gives us what? The same matrix, identity matrix. Now let us take minus I. What will be minus I? Minus 1, 0, 0, minus 1. So the function, take this matrix to its square. So what will be f of minus I? It will be minus 1, 0, 0, minus 1, minus 1, 0, 0, minus 1. So if we calculate this, minus 1 into 1, 1, and then this 0, and after calculation, we will get this to be 1, 0, 0, 1, which is nothing but our identity matrix. So what we got is I also gives image I, and minus I also give us image I. So we have two different pre-images for a same image, and hence this is not injective. So not injective. Now let's check what? Surjective. So what does surjectivity says? For every element in the image, there must be a pre-image. So let us take an element which must be in image. So it must have a pre-image, and we will show it does not have any pre-image, and that will fail to be surjective. So let matrix M to be 0, 1, 0, 0. So for this to be surjective, this particular matrix must have a pre-image. So there should be a matrix A, B, C, D such that the square will give us this matrix. So A, B, C, D into A, B, C, D must have given what? 0, 1, 0, 0. That's what surjectivity says. So if we calculate this, what it will be? A square plus BC, A, B plus BD, AC plus CD, and this last term will be CB plus D square. So this is what this matrix multiplication gives us, and this should be equal to what? 0, 1, 0, 0. Now if we compare all the terms, what we get from here? So we take B common, A plus D must be equal to 0, And from here we get what? A square plus, sorry, this should be 1 and this should be 0. So and from here what we get? We get C A plus D must be equal to 0. So we take these two equations and compare them, not this one. So number two numbers are multiplied and they are giving 0. So either one of them has to be 0. But since B into A plus D is giving what? 1. So if A plus D is 0, this equation will not satisfy. So A plus D cannot be 0. So from here, this implies C must be what? 0. So from here we get what? C must be 0. Now if C is 0 and we put it in this first equation, what we get is, if C is 0, this implies A square plus BC, which was 0. This implies A square is 0 and that gives us what? A is equal to 0. And also if we put it here, we'll get what? 0 plus D square is equal to 0. So D square is equals to 0 and D has to be 0. Also, since this is 0, so D square is 0. This gives us what? D is also 0, right? So A is also 0 and D is also 0. Then if you put 0, 0 into B, this will whole become what? 0, and hence there will be no such matrix that will exist and give us this to be as a output matrix, and hence this is not surjective. I hope you understand this question. So let us look at your next question, which is question number 25. So this question asks you to calculate the value of the sum and then you have to tell the value of alpha. So let us look at how this sum looks like. So this is what cot inverse, 2 cot inverse, 8 and so on till 100 terms. So first convert this cot inverse terms in tan inverse and so on. So we can write this as, we can convert it in tan and we can write this as tan inverse 1 by 2 plus tan inverse 1 by 8 and so on. And why we can do that? Because cot inverse x is equal to tan inverse 1 by x for x greater than 0. So this is why we can convert this in this particular form. So now, if when we have done this, so we can see a pattern. So this looks like tan inverse of 1 by 2 to the power n. And this sum I can write this as summation running from n is equal to 1 to 100. So this is how we can see the pattern inside the terms, which is 1 upon 2 to the power n square. 2 into n square. So now we can manipulate this further and we can write this as tan inverse 2 upon 4n square, and now this can be written as tan inverse 2 upon 1 plus 4n square minus 1. And why we are doing this? Because we want it in some form of tan inverse identity. That's why we did this. That's why we are doing complete this step. So now this further can be written as tan inverse, this is 4, 2 upon 1 plus 2n plus 1 and 2n minus 1. This is nothing, we are using a square minus b square for the denominator term. Now this term again can be written as tan inverse 2n plus 1 minus 2n minus 1 whole divided by 1 plus 2n plus 1 2n minus 1. So why we did this? Because we converted it in of the form tan inverse x minus y upon 1 plus xy. And we can now easily use the identity of tan inverse a minus b. Tan inverse a minus b upon 1 plus ab. So that's why we converted in this particular form. And there, so finally what we want summation. So we want summation n is equal to 1 to 100
of this term, right? This is tan inverse 2n plus 1 minus 2n minus 1 whole divided by 1 plus 2n plus 1 and 2n minus 1, right? This is what your final term is. So now when we apply that formula, we will get tan inverse of 2n plus 1 minus tan inverse 2n minus 1. And the sum is from n is equal to 1 to 100. Now just put the values of n. Put the values of n and this will open as tan inverse 3 minus tan inverse 1 plus tan inverse 5. Then you will get minus tan inverse 3. Then you will get plus tan inverse 7 minus tan inverse 5 and so on. So this terms will go on. So now you can clearly see tan inverse 3 cancels out, tan inverse 5 cancels out, and so on the terms will cancel. You will be left with minus of tan inverse 1 and the last term, which will be tan inverse of 201. That will be the last term, 201. So finally you will be left with what? Tan inverse of 201 minus tan inverse of 1. So this is what the final terms will be left. Now I know again tan inverse of a minus b is what? This can be tan inverse a minus b is what? Tan inverse a minus b upon 1 plus a into b. So this is nothing but my final calculation gives me tan inverse of 200 upon 202. Now I have to compare this with cot inverse alpha. Now cot inverse alpha can also be written as cot inverse alpha is also what? Tan inverse 1 by alpha. When you compare it with this, you will get alpha as 202 upon. So comparing, you will get alpha as 202 upon 200. So the value of alpha will be, when you cancel this, 101 upon 100. So this will be 1.01. So the final answer is option number A, 1.01. So all you needed to do this is the recursive summation relation in tan inverse terms. So now next question, your question number 26, which is a very easy question. And what you all need to do is just know this particular formula for this. So we know limit n tends to infinity a1 to the power n plus a2 to the power n plus dot 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 some ak terms to the power n whole to the power 1 by n is nothing but this is maximum of a1, a2 and so on ak. So whatever is the maximum term that you can see, that is the value of this particular limit. So in this expression, when I compare, I can write this expression as limit n tends to infinity 1 to the power n, 1 by 2 to the power n and so on 1 by 200, 2026 to the power n, to the power whole 1 by n. Now compare, your a1 is 1, a2 is 1 by 2, ak is 1 by 2026. I want maximum of all this. So maximum is 1. So this is my final answer. So the value of this limit is nothing but 1, which is already marked as a correct answer. So the value of this limit is 1. So the answer is 1. Let us move on to your next question. So this is asking for continuity of this function at point 0 or 1. So we want to check the continuity of this particular function at 0 and 1. So first let us write this function in simplified form. So what this function is? So your fx is greatest integer x square minus x plus mod minus x plus greatest integer of x. This is what is given to you. So we can simplify and write this as, we know x is written as greatest integer of x plus fractional part of x. This we all know, right? So from here I can write minus of fractional part of x as minus x plus greatest integer x. Also I know the range of greatest integer, the fractional part. This is from 1 to 0. The range of the fractional part is from 0 to 1. So this will always be a positive. Negative will give you a negative quantity. But here it is mod. So finally overall, this quantity will become greatest integer fractional part of x. So finally this quantity will become fractional part of x. So first this becomes mod of minus greatest integer. Now since fractional part function has the range from 0 to 1, so the fractional part will come out of the mod and it will be like that, right? So now we want to check for this greatest integer and fractional part at 0 and 1. So let us look at the behavior of these two functions around 0 and 1. So this is my x square minus x. So by Bevikov method we know it has root at 0 and 1. So this has root at 0 and 1. So by Bevikov method, this is positive here, negative here and positive here. This particular function, this is by Bevikov method for this function. Now greatest, this fractional part, the fractional part function, how this looks like. So the fractional part around 0 and 1. It is 0 at 0. Then this is the behavior of this. So this is how our fractional part functions behave. Now I want to check at 0 and 1. So I'll evaluate the value and limits at 0 and 1. So at 0. So let us look at first x is equal to 0. What is the value of function? So f of 0 will be, just put the values. This will be 0 square minus 0 plus fractional part of 0, right? So this will be 0 plus 0. So at 0 the value is 0. Now I want limit. So I want its left hand limit and right hand limit. So let us evaluate right hand limit at 0. Let us evaluate the right hand limit at 0. So I want limit x tends to 0 positive of this particular function. So now check. From 1 you are approaching to 1 from, you are approaching 0 from positive side. So when you approach 0 from positive side, how these functions behave? So this is how I am approaching 0 from its positive side. This function is a very small negative quantity. This function has a very small negative quantity, and greatest integer of a very small negative quantity is what? Minus 1. So this will give me minus 1. So this will give me minus 1. And fractional part, how this behaves from 0 positive. So now I am approaching 0 from positive side. This will go to what? 0. So this will go to 0 and my final limit is minus 1. So right hand limit is not equal to the value. So this is not continuous at 0. So not continuous at x is equal to 0. Now let us check at x is equal to 1. So at x is equal to 1. Let us check the value first. So f of 1 will be 1 square minus 1 plus greatest fractional part of 1. So this is again 0 plus 0. This is 0 plus 0, which will be 0. Fractional part of 1 is 0. At 1, the fractional part value is 0. And this value also calculated and it came out to be 0. Now left hand limit. Now left hand limit at 1. So this will be limit x tends to 1 from negative of x square minus x plus fractional part of x. Now this you are approaching 1 from negative. So 1 from negative will be this approach. This is again a very small negative quantity when you are from 1 left. So again this will limit go to a very small negative number. So the greatest integer of a negative number, a small negative number, is minus 1. And fractional part you have to approach from 1 left. So when you approach 1 from left side, so when you are approaching 1 from left side, it will take value 1. So when you approach 1 from left, the fractional part takes its value as 1. So from the left, this value is 1. So this limit is 0. So left hand limit and value is equal. Now let us check the right hand limit. So limit x tends to 1 from positive now. So now 1 from positive, I'll check the value of this particular function. Now when you approach 1 from positive side, this function is coming this way and this is a small positive quantity. A small positive quantity, greatest integer is always 0. Plus, when you approach 1 from positive side, the fractional part also goes to 0. So this is also 0. So my value, left hand limit and right hand limit, all three are equal. So this is continuous at x is equal to 1. So continuous at 1 and not continuous at 0. What is the correct option? It is continuous at 0. This is incorrect. This is incorrect. So this is continuous at 1 but not continuous at 0. So the B option is correct answer. So let us move on to our next question. It says the function is not differentiable at 2 points. One is x is equal to alpha and the value of alpha is given to you as 2. And at x is equal to beta. Then you have to tell the distance of this alpha beta point from this particular line. So all you need is to calculate the beta value and the distance from this particular line. So let us see how beta will comes out. Now what is your function? Your function is x square plus 1 mod of x square minus ax plus 2 and this is cos mod x. Now I know cos mod x is nothing but cos x because when you put a negative, cos will become positive. When you put positive, cos is again positive. So function is nothing but x square plus 1 mod of x square minus ax plus 2 plus cos x. So this was just to confuse you. Now I know this function is differentiable. Cos x is differentiable. This particular thing, x square plus 1 is differentiable. But it says it is not differentiable at 2 points. So those 2 points can be only come from this particular mod part. So the only way that 2 points can not differentiability come from this mod part. And if you see for a quadratic, the graph is either above the x-axis or below the x-axis or it cuts it exactly at 2 points. So these are the 3 ways this graph can be drawn. Now if it is above, this will always be positive. So you will get this mod will be removed. It is negative, the mod will be removed with a negative sign. So overall function will become differentiable. It will just become a polynomial function. But it says it is not differentiable at exactly 2 points. So the graph can only be, so the graph of this particular expression, so overall graph of this x square minus ax either this way or it will be of this form. It will cut the x-axis at exactly 2 points. So overall it will look like in this manner. So it will be this, then this will take a sharp turn and go on. Or second form can be, it will go like this, take this turn and go down. So these are the 2 possibilities. So these 2 points where it will take its root values, the value where it will be having its root, those are the points where the function will be not differentiable because those are the points where it will take the sharp turn. So these are the points of its sharp turn. And sharp turn, there is no differentiability. So all I want is the root of this particular expression. So for this, I am given 2 points, alpha and beta. So x square minus ax plus 2 has alpha beta as its root. I can conclude this directly because these are the points where it will have sharp turn. So you are given alpha is equal to 2, alpha is equal to already 2 and we know for a quadratic, product of root is what? Alpha into beta you will get as 2. Product of root is this value upon a is 1, so that is 2. So from here you can directly say your beta is what? 1. So now I got my point beta, point of non-differentiability, which is 1. So my beta value is 1. So my point becomes 2 comma 1. Now I want the distance of this point from this line. So distance of this point from the line 12x plus 5y. So this is my point, let's say 2 comma 1. This is, let's say, your line. This is your line 12x plus 5y plus 10 is equal to 0. So you want the distance. So apply the perpendicular distance formula. So that will be what? 12 into 2 plus 5 into 1 plus 10 upon under root 12 square plus 5 square. And we take the mod value. So this will be what? 12 to 24 plus 5 plus 10. And root 12 is 144 plus 5 square, which is 25. It will be 169. So the root will be 13. And when you solve this, this is 34 plus 5. 39 upon 13. So final calculation gives you 3. So the distance of this point from this line is 3 units. So my answer is option number C. So my next question. So this says f be a continuous function and suppose this particular value, this limit is p. So for any alpha in real number, this particular limit is coming out to be p. Then we have to comment on these 4 options. F is differentiable at alpha if LH, left hand derivative and right hand exist. It is differentiable and value is p, differentiable and value is p by 2, or f may not be differentiable. So whenever you see this type of question, you can consider a basic example at which function will be continuous everywhere, and you can consider a point where it will be not differentiable. So let me take fx is equal to mod x. And I know my mod x function is not differentiable at x is equal to 0. So let your alpha is equal to 0. I want to compensate differentiability at alpha, right? So I can take alpha as 0 for this particular function. And I know this is not differentiable. And let us evaluate this particular limit for this function. So what is the limit? Limit h tends to 0, f of alpha plus h. Alpha is 0. So this will be just f of h minus f of alpha minus h. Alpha is again 0. So this will be f of minus h upon h. Now what is my function? Function is mod x. So this will be limit h tends to 0 mod h minus mod of minus h upon h. So what you will get? Mod h, h is a positive number. You can consider h to be a very small positive. So mod h will be h minus negative of mod h will be again positive. So this will be h upon h. And here you have limit h tends to 0. Now numerator become perfect 0 and denominator is h. So this is nothing but 0. So the value of p, so I'm getting p as 0. And it says p is any real number. So this is a real number. So I'm getting this particular finite limit as 0. It is 0. So value of p is 0. So I'm getting it as a real number. But I know this function is not differentiable at 0. So I can clearly discard my option number A, B and C. It says it is differentiable. It says it is differentiable. It says it is differentiable. But f may not be differentiable at alpha. So this is how you can approach this kind of questions. Now next question says, this is a function defined in irrational and rational. So this kinds of function are called Dirichlet function. So this kind of function are called Dirichlet functions. So I have to tell about its continuity and differentiability. I have to comment on its continuity and differentiability. So all you need to know is this type of function. Whenever you see fx as some function gx and some function hx, this is defined for rational and this is defined for irrational. Whenever you see this type of function, this is always continuous only at, so this is only continuous at points where this gx will be equal to, whenever this function gx, whenever you see this gx, it will be equal to hx. So this types of function is continuous only at those points where these two branch functions are equal to each other. So all we need to check is when sin x will be equal to tan x. So we want to evaluate sin x is equal to tan x and find the points in this particular intervals. So we want to find the points for this. So we know I can write tan as sin upon cos. So I can take sin common again, and this will be 1 upon 1 minus cos x is equal to 0. So I just skipped a step, which you can write sin x is equal to sin x by cos x, and then you take it on the left side and you will find this. So either sin x will be 0 or this will be 0. So from here, if sin x is 0, in this particular interval from minus pi to pi, so the only point it is asking from minus pi to pi. So sin x is 0 only at x is equal to 0. And this will give me, again when you solve this, you will get x is equal to 0. When you solve this, you will get cos x is equal to 1. And in this particular interval, cos x is 1 only at x is equal to 0. So the only point I am getting is x is equal to 0. So this function is continuous only at x is equal to 0. So I can conclude continuous at x is equal to 0. Now you want to check about differentiability as well. So since it is continuous only at 0, I'll check differentiability also only at 0. So what will be the derivative of this function? So the derivative, when you evaluate the derivative, so let me do it here. So what will be the derivative? F dash x. So your f dash x will be what? G dash x, h dash x. So what is your gx? Sin x. Derivative of sin is cos x. So this will be when x belongs to irrational, and this will be sec square x when x belongs to rational. Now you only want to check it at point 0. So what will be the value of cos x at 0? So cos of 0 is 1, and this is equal to sec square at 0, which is also 1. So cos 0 is equal to sec square 0. So the value are equal at both the points. So my function is differentiable at x is equal to 0. Since the value of derivative are equal, left hand and right hand derivative are equal at this particular point, so my value will be 1 and 1. So this function is differentiable at x is equal to 0. So what I'll conclude, continuous at some points, some point or 1 point, it means the same of this interval, and differentiable at all these points. So what the point of continuity was? Just 0, and it is differentiable as well there. So the language says continuous at some points and differentiable at all these points. So my sum point is only 0, and it is also continuous at this points. So my correct option is option number D. So let us move on to your next question. This is also from derivative, and it uses the concepts of polynomial. So what it says, let fn be a general polynomial, let fx be a general polynomial, and you are given its value at 0, derivative at 0, double derivative at 0, or second order derivative at 0, and you are given this condition. We are given the third derivative is equal to the fifth derivative. So the third derivative is equal to the fifth derivative. So consider the general function. So your fx is an x to the power n, an minus 1, x to the power n minus 1, and so on. Now we want to evaluate this condition when this will be true actually. So you see the third derivative. When you do its derivative once, you will get an, x to the power n minus 1, and so on terms. So when you will come to the third derivative, f double dash of x, triple dash actually, what you will find is the degree. The degree will be n minus 3. So this will give me degree as n minus 3, because the highest power that will be left will be n minus 3. And for the fifth derivative, when you will see fifth derivative, the highest degree will be my n minus 5. So you can evaluate that. The function, the polynomial degree was n. When you will calculate the third derivative, your degree will be n minus 3, and for fifth it will be n minus 5. Now it says the third derivative is equal to fifth derivative, which means a n minus 3 degree polynomial is equal to a n minus 5 degree polynomial. So this is never true. This can never be true. This can never be true unless this is true. So this can never be true unless these degrees become 0. So until and unless this becomes 0, this can never be true. So my highest degree for this polynomial function is 2. As you will reach a 3 degree polynomial. For example, let's say my fx was an, let's say my fx was a3 x to the power 3 a2 x2 a1x plus a0. This is a 3 degree polynomial. So now the third degree will be what? When you will calculate its third derivative. So you will get what? You will get 3 into 2 into a3. This will be your third derivative. It will be 6a3. But when you will go to the fourth and fifth derivative, they will directly come out to be 0. So when you will calculate d5f by dx5, it will directly come out to be 0. Now it says this is equal to this. So this term will be 0. So my a3 will be 0. And all the coefficients after a3 will be 0. So what this condition says, all your coefficients from 3, a3 is equal to a4 is equal to a5 and so on, they all are 0. So what my polynomial reduces to? My polynomial reduces to, it is nothing but fx is some a0 plus a1x plus a2x square. This is the polynomial that will be formed by this particular condition. Whenever you see a derivative equal to some other derivative for a polynomial, then its degree will be till the small and less than 1. So it is 3 here, so it will be less than 1. So it will be 2. Maximum degree polynomial, it can be of degree 2. So now we are given 3 conditions on this. f0 is 1. So put f0. So you'll put f0, x is 0, so you'll get a is 0, which is given to be 0. Now derivative at 0 is 1. So its derivative will be, f dash x will be a1 plus 2a2x. Now its derivative at 0. It will be 0. This will be just a1. This is what? 1. So this implies a1 is equal to 1. And now double derivative, that will be nothing, just 2a2. So double derivative is 2a2. And when you put it x is equal to 0, this is 4. This implies this is equal to 4. So your a2 value is 2. So what is my polynomial? My final polynomial is fx is equal to x plus 2x square. This is my final polynomial, x plus 2x square. Now you want its value at 5. So what will be f5? 5 plus 2 into 5 square. 25, 50, and this will give you 55. So my final answer is option number A, 55. So this is how you approach by this particular condition. This was an important condition to be noted for this question. Now next, this is a very easy question. All you need to just know how you will apply AM/GM inequality. So this is what 3x plus 4y is equal to 14. So you can write this as x plus x plus x plus y plus y plus y plus y upon 7. This is the arithmetic mean of these numbers. This is the arithmetic mean AM of these numbers. And I know AM is always greater than or equal to the geometric mean. So geometric mean will be 1 by 7 root of x cube y to the power 4. So by AMGM equality, I know this term will be greater than or equal to this particular term. Now, you know the sum of this is 14. So this will be 14 by 7 is greater than or equal to 1 by 7th root of x cube y ki power 4. So this is 2 is greater than or equal to x to the power 3, y to the power 4. Now take 7 power on both sides. So this will become 2 to the power 7 is greater than or equal to x cube y to the power 4. Now this is what? This is 128. So the value of this term is less than or equal to 128. So the maximum value is 128. So it was an easy question. Now let us look at this question. So this is asking for increasing, decreasing and maxima, minima. So we will approach this using derivatives. So what it says, f is a differentiable and strictly increasing function such that f0 is less than 0 and it is less than 2 pi. So two information about f I have. It is strictly increasing and this particular thing. So what I can say, from 0 to pi by 2. This is, let's say, 0. This is 2 pi. So from 0 to 2 pi only it is given. So the value at 0 is less than 0. So it will be somewhere here. And at 2 pi it is greater than 0. So it will be somewhere here. And function is what? It is strictly increasing. So function will move like this. This is strictly increasing. So it will not decrease, it will only increase. So this is how roughly my fx is. So the function is 0 at a point, let's call this point alpha. So when you move from negative to positive, the function takes a value 0 at least one point. And it was strictly increasing, so it will take the value 0 at exactly one point, because it won't increase and it won't decrease after that. It won't behave like this. When you go once, it will not come down because the function is strictly increasing. So from this two condition, I can conclude it will have only one value at which the function will be 0. Now let us look what it defines further. Now it says you want this particular value. F of t is 0 to t fx dx. So I want to comment on the increasing, decreasing and maximum, minima nature of this capital F. So I want its derivative. So the derivative will be f dash t will be, now you know derivative of a integral with a variable term t or a variable function. So this will be ft. So derivative of this function is nothing but ft. So derivative of this function is ft only. And I want to comment its behavior on 0 to 2 pi. So I only need to check the behavior of this function ft in 0 to 2 pi. So what I have? So how derivative will behave? So how the derivative will behave? Let's say this is your point 0, this is your point 2 pi, and this is the point at which the root is 0. This is your point alpha. Now function is negative from 0 to alpha. So function, I can say f dash t is negative from 0 to alpha. So from 0 to alpha, this derivative is negative, and after that it becomes positive. So from 0 to alpha, the derivative of this function is negative, and after that it becomes positive. So from here it will go down and then it will increase. At this particular point it will attain the value 0. So it is decreasing from 0 to alpha, and it is increasing from alpha to 2 pi. So at alpha it will give me what? At alpha, it will give me what? At alpha, I'll get a point of minima. At alpha, I'll get point of minima. Or how you can say that? or you want its derivative f dash alpha also. So you can see like this also. It is 0 by first derivative test. This is 0 alpha and 2 pi. From 0 to 2 alpha, the ft function is negative. So here it is negative, and from alpha to 2 pi it is positive. So this function ft, that is what derivative is. So it is negative in 0 to alpha and positive in alpha to 2 pi. So derivative is changing its sign from negative to positive. And by first derivative test, we know when derivative sign changes from negative to positive, the functions decrease first and then it's increase. So that is what I told you here. So function has a minima at alpha. So what is the correct option? Function has a minima in the interval 0 to 2 pi. It is not increasing. It will decrease and increase. It is not having a maxima. It is having a minima. And it is not decreasing. It is first decreasing and increasing. So the only correct option is D. It has a minima at alpha in this particular interval. Next is again from your maxima minima question. So I want to tell set of all real values of x for which this function is strictly increasing. So again we will use the derivative test and solve this question. What is your function? Your fx is sin x plus cos square x. Find its derivative. So derivative will be cos x plus 2 cos x, and derivative of cos x is minus sin x. Put it equal to 0 and find the critical points. So this will be cos x can be taken common. This will become 1 minus 2 sin x is equal to 0. Now find the points. First when cos x is 0 and then when this will be equal to 0. So you will get points as cos x is 0 in this particular interval. You have interval from what? It is asking in your options and you are given interval from 0 to 2 pi. So this is 0 at pi by 2. Next point it will be 0 at, that will be 3 pi by 2. So cos x is 0 at pi by 2 and 3 pi by 2 in this particular interval 0 to 2 pi. So it is 0 at pi by 2 and 3 pi by 2. So next, 1 minus 2 sin x. So 1 minus 2 sin x is equal to 0. This implies sin x is equal to half. So we want points at which sin x is half. So sin x is half at pi by 6 and 5 pi by 6. So these are the 2 points in which sin x is half. Sin x takes values half in this 2 particular values, pi by 6 and 5 pi by 6. So these are the 2 points in which sin x is taking value half. Right. So now I want to check the, now I want what? I just need to check the sign of the derivative. If it is positive, negative, in which particular domain. So here it is your 0 and let's say here it is your 2 pi. So from 0 to pi by 6, 0 to pi by 6, cos x is positive and this term you need to see if this is greater than 0 or not. So in 0 to pi, cos x is positive and 1 minus sin 2x. This will also be positive. So derivative is positive. From pi by 6 to pi by 2. From pi by 6 to pi by 2, cos x is still positive, but sin x will be negative. So this is, derivative is negative. From pi by 2 to 5 pi by 6. From pi by 2 to 5 pi by 6, you will again find this is from pi by 2 to 5 pi by 6. Cos x is what? Cos x is still positive. And when you will find the value of this, you will get this is also positive from pi by 2 to 5 pi by 6. So overall positive. Derivative is overall positive. Then in next, you will find it to be negative. In next interval, you will find this as a negative value, and from 3 pi by 2 to 2 pi, when you will check the sign of derivative, put any point from this interval, you will find it to be positive. So function is increasing in which interval? In which the derivative is positive. So my interval is 0 to pi by 6, pi by 2 to 5 pi by 6, and 3 pi by 2 to 2 pi. So my final answer is option number D. 0 to pi by 2, pi by 2 to 5 pi by 6, and 3 pi by 2 to 2 pi. So all you needed to do is just first derivative, find the critical points or stationary points, and check the sign of derivative in these intervals. So this is what function asked. So now this is your next question, and it says fx is a function sine cube rx, r is any non-zero real number, and you have to tell which of the following statements is true. Now see, for this type of question, when you see a general r, you don't need to do that by solving it taking any r. So since here you see r is any number greater than 0 in the first two options and r is any number less than 0 in the next two options. So what is the best approach to do? Just assume a value of r greater than 0 for these two and assume a value of r less than 0 for these two particular options. Because if we discard a statement by taking an example, then that statement will be incorrect. So let us take a value of r, and the easiest one for r greater than 0 is 1. So let r is equal to 1. So for these two cases, I am taking r to be 1. So my functions become sine cube x. And these intervals become pi by 2 to pi, and this becomes 0 to pi by 2. So for the first two options, I am taking r to be 1. Now you want to tell the nature of its increasing and decreasing. So you just use the first derivative test. So just derivative it. So f dash x will be 3 sine square x cos x, and put it equal to 0. Find its critical points. So from here I'll get x is equal to 0 and pi by 2 and pi. These are the 3 points which I'll get for this. In these intervals I need to check from 0 to pi. For the both options I'll check from 0 to pi. So 0 and pi are not included. So when you plot them, so this will be 0, this will be pi by 2, and this will be your pi. So when you do this from pi by 2, you need to check the sign of derivative if it is positive or negative around pi by 2. So put any value between 0 to pi by 2. What you will find, so this term is always positive, this is positive, cos x is positive from 0 to pi by 2. So positive here and derivative is negative here. So derivative is changing sign from positive to negative, which means function is increasing in this interval and decreasing in this interval. So in 0 to pi by 2 it is increasing, but it says in 0 to pi by 2 it is decreasing. So this is wrong and this is also wrong. Both are opposite to each other. So first two options are incorrect. Now similarly take r is equal to 1. Similarly, as you took r is equals to 1, take r is equal to minus 1 for these two cases. So then you will get fx as, so your fx will become minus sine cube x. Since this will be sine cube of minus x and minus comes out, so this will be minus sine cube x. Now again, find its derivative. So you will find minus 3 sine square x cos x is equal to 0. And what these intervals will be? This will be minus pi by 2 to 0, and this will be minus pi to minus pi by 2. So this is what the interval becomes, and this is my derivative, and put it equals to 0. So you will find what will be the roots. Now x will come out to be minus pi, next will be pi by 2, minus pi by 2 and 0. So cos x is 0 at minus pi by 2, sine is 0 at minus pi and 0. So again, when you look it on the number line, so you will get minus pi, this will be minus pi by 2 and this will be 0. Now again, check the sign of derivative around this point minus pi by 2. So from 0 to pi by 2, 0 to minus pi by 2, I know my cos x is positive, but overall it is negative. So this will be negative and positive here. So this function is increasing from minus pi by 2 minus pi by, from minus pi to minus pi by 2 and decreasing from minus pi by 2 to 0. So what is the correct option? It is decreasing from minus pi by 2 to 0. So my option number C is correct for this question. So this was a good question. All you need to do is just take and assume a value of r. Now next question, this says g is a differentiable function such that g dash x is greater than 0. And we have to comment about increasing and decreasing nature of these functions. Now for increasing and decreasing, first thing that clicks in your mind is derivative. So is this function a derivative of some function? No. But if I manipulate it, if I take hx as 2gx g dash x. Now since g dash x is also positive, 2 is also positive, so this will overall remain greater than 0. This term is completely positive, 2 is a positive number, so this will always be greater than 0. Now I know if you assume h dash x like this is the derivative. If you assume it this, so derivative is positive. Now what functions gives you this derivative? What is the function that gives you this derivative? So what we can take? We can take hx as g square x. So when you assume hx as g square of x, what its derivative will be? The derivative will be 2gx g dash x. That is what we have assumed to be. We have just multiplied with 2 and assume it to be a derivative of some function. Now this function comes out to be g square of x. Now the derivative is positive. So from first derivative test, I know my function hx is always an increasing function. So this implies hx, which is your g square of x, this is an increasing function. Now I know if a square of a function is increasing and if I take a square root, so you take square root of a function, that is also increasing. So if a function is increasing, so square root of that function is also increasing. And I know square root of any number is equal to mod x. Square root of any expression square is equal to mod x. So from there, I can directly say this is nothing but mod of gx. So my mod of gx is an increasing function. So from here, I can say my option number C is correct. So all you need to do is just assume this function because this is of this form, gx into g dash x. And after that, all you need to remember is this property, square root of a square number is mod x. This is not x, but this is what? Mod x. So mod of gx is an increasing function. So this is a very interesting question and this uses multiple concepts, and by looking at the question, you may get confused or you may fear because this looks very lengthy and big. But we will look at it how we can approach this question. So first, this is asking p of minus t minus 1 and you are given pt. So find p of minus t minus 1. So p of minus t minus 1 will come out to be, if you put it here, you will get minus t minus 1, minus t minus 2, minus t minus 3 and dot 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 minus t minus 2026. It is going till, sorry, this is going, yes, this will be minus 2026 because we are subtracting one, that will be added here. Also, there was a little bit mistake in this question. Make this term as 1 upon 2026. So this is 1 upon 2026, not 1225, right? So now take minus common. These are 1, 2, 3 till 2026. So these are 2026, even number of terms. So when I take a negative common, so this will be minus 1 to the power 2026 and this becomes t plus 1, t plus 2 and so on, t plus 2026. I can write it in this way and this is negative, so this becomes overall positive. So this is my function and there was a factorial also, so that will be divided by 2025 factorial and here also 2025 factorial, right? So now what you do is just, all you need to do is just assume this function as a new function qx. So let qx is equal to t plus 1, t plus 2, dot dot dot, t plus 2026. When you do this, we will form a pattern of this way. So that's why I assume this as a function qx. Now take log. Why we are taking log? Because derivative of a product function 2026 is very lengthy process. So we take log on both sides. So take ln on both sides. This will become ln of t plus 1 plus ln of t plus 2 and so on ln of t plus 2026. Now take the derivative. So this will be q dash x upon qx is equal to 1 upon t plus 1 plus 1 upon t plus 2 till dot 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 1 upon t plus 2026. Now just multiply qx there, you will get, so when you multiply qx here, you will get q dash x as, what is your qx? T plus 1 till t 1026. So this will be t plus 1, t plus 2, dot dot dot, t plus 3, t plus 2026 divided by this term. So I can assume this term here. So assume this is this term here. This term complete is here. Now what is q dash x? T plus 1, t plus 2, t plus 2026. And this is nothing but, this is my what? This is my p of t minus 1. My p of minus t minus 1 was this. My p of minus t minus 1 was this term. I assume this as qt. So I can write this as qt upon 2025 factorial. So what I can do, I can write this integral as 0 to 1. This is 1 upon 1 t plus 1 plus 1 upon t plus 2 dot dot dot, and this is what? This is qt upon 2025 factorial. This is what it is. If I assume this as qt, this becomes qt upon 2025 factorial, p of minus t minus 1. Now see, this is what? This is qt into this addition terms, right? Qt into this particular term. So this is nothing but, this is same as this qt and this term. So what I can replace it by? I can replace it by q dash t. So this integral becomes what? This becomes 0 to 1, 1 upon 2025 factorial into q dash of t dt. So this simplified as this. Now I know this is a derivative, and when you take integral, this is nothing but 1 upon 2025 factorial is taken common, and this will become q of t, and limit is from 0 to 1. So when you put the limit, you will get q1 minus q0. I am doing it here now. I am solving this case now here. So from that, I am putting the values and I am solving it here. So this will be q1, this will be q1 minus q0, and here it was 1 upon 2025 factorial. So this is what my terms are. Now just evaluate q1 and q0. Put 1 here. q1 will be 2 into 3 till 2027. So your q1 will be 2 into 3 till 2027 minus q0 will be 1 to 2026. 1 into 2 into till 2026. And this is whole divided by 2025 factorial. So this is whole divided by 1 upon 2025 factorial. So this is what I can multiply 1 here. Nothing changes. I can write this as 2027 factorial minus 2026 factorial whole divided by 2025 factorial. Now take 2027 common. Take 2027 common here. What you will get? This will be 2027 and this will become 2026 factorial minus 2026 factorial upon 2025 factorial. So let's do it here. So this will become what? I can take 2026 factorial common, and this will be 2027 minus 1 whole divided by 2025 factorial. So this is 2026 only, and when you take this as 2026 into 2025 factorial, So I can again write this as 2026 into 2025 factorial into 2026 upon 2025 factorial. So this cancels out. So you are left with 2026 into 2026, which is 2026 square. So this is the final answer for this question. So what we did, we just assume P of minus T minus 1 we calculated. We assume this part as QT or QX. Okay, let me just put it QT. Wait, so it was T. So this was not X, so it is T everywhere. So put it T, put it T. So this is what I assumed as QT. So this is also QT. So that is what I just assumed this function to be. So my Q dash T came out to be QT into this term. So QT into this term. So this is what it is returned. And so I just replaced it by Q dash T. So this next question is from your definite integrals, and this tests your knowledge of even and odd function. So what it is written, I can write this as, first I can write this as minus pi by 6 to pi by 6 pi upon 1 minus sine of mod x plus pi by 6, and I can distribute the other way as minus pi by 6 to pi by 6, and this is 4x to the power 11 upon 1 minus sine of mod x plus pi by 6. So now when you look at this function, the numerator is an odd function. So this is an odd function. Because of the mod, denominator will become an even function. So the overall function is an odd function, and we know from minus a to a, integration of odd function is always 0. So this integral is completely 0. So this complete integral is this is equal to 0. So what I am left with is just this particular part. Now this is an even function. For an even function, I can distribute this limit. So this will become pi I'll take outside, and this will be from 0 to pi by 6, 1 upon 1 minus sine. And now mod x, from 0 to pi by 6, x sine is positive. If you add pi by 6, that will be pi by 3. So from this to this interval, this complete sign will always be positive. So I can write this as x plus pi by 6. So from 0 to pi by 6, mod x is positive, so I can distribute it like this. Now let x plus pi by 6 is equal to u. So what I'll get, from 2 pi, limit will change to, when it is 0, this will become pi by 6, and this will become pi by 3. And this will be 1 upon 1 minus sine u du. This was dx here. This will become 1 upon 1 minus sine u du. Now just multiply with 1 plus sine u in the numerator and denominator. You will be getting pi by 6 to pi by 3. Numerator will become 1 plus sine u. And denominator will become 1 minus sine u, 1 plus sine u. That will be 1 minus sine square u, that is cos square u du. Right? Now take it separately. This will become sec square u. This will become sec u tan u. So this becomes 2 pi integration from pi by 6 to pi by 3. This will become sec square u plus sec u tan u du. Now I know integration of sec square as well and sec u tan u as well. So this is nothing but 2 pi. Integration of sec square u is tan u, and for this it is sec u. Now put the limits, pi by 6 to pi by 3. So when you put the limit, what you will get as your final answer? This will be 2 pi. Value of tan at pi by 3. Tan of pi by 3 is root 3. Sec of pi by 3 is 2. Minus tan of pi by 6. Tan of pi by 6 is 1 by root 3. And sec of pi by 6 is 2 by root 3. So this is what you evaluate. So this will become 2 pi root 3 plus 2 minus 2 plus 1, 3 by root 3 will become root 3. So root 3 cancels out. Your final answer is 4 pi. So your correct option is option number D, 4 pi. So this was what you need to do. Now let us look at your next question. This is again from your integrals. Now here, if you have to see, this term is ln of x. Integrate it with respect to ln of x. So what mistake you can do? You can change this as from minus infinity to ln of pi by 2, and you will directly take derivative of ln x is 1 by x, and this will you will take at dx. So this is what generally you make mistake. But here the limit is also in terms of ln of x. Now we have changed it to the integration of dx, so we have to change the limit as well. So this is a wrong step. What will be the right step is, now since this is for ln x to ln of pi by 2, so limits of x will be from 0 to pi by 2. This is what you need to change. So when you convert it in this form, the limits will become from 0 to pi by 2. So my integral is nothing but 0 to pi by 2 x square upon 10x into 1 by x dx. Now x cancels out. This is nothing but integration from 0 to, this is 0 to pi by 2 x, and 10x can be written as cot x dx. Now apply by parts. Now apply by parts. We will apply integration by parts. So this is your first term and this is your second term. So apply the formula. So you will get x as it is, integration of cot x, that is ln of sin x, and the limit is 0 to pi by 2, minus integration, derivative of your first term is 1, integration of second is ln of sin x dx, and the limits are from 0 to again pi by 2. Now this will become 0. Check why this will become 0. When you put pi by 2, sine of pi by 2 is 1, ln of 1 is 0. So this is 0, and when you put 0, this will become 0 into 0 form. This will become 0 into infinity form. Not 0 into 0, this will become 0 into infinity form. So this is your question, homework. Check why limit x tends to 0, x ln of sin x will be 0. Check this limit, you will find it to be 0. So this complete term will be 0, and we know this is a standard limit, ln of sin x from 0 to pi by 2. We know the value of this limit is, pi by 2 ln of 2. So the value of this limit is minus pi by 2 ln of 2. This is a standard limit we know from your class 12th. So when you put it here, your final answer will be minus minus plus. So the final answer will be pi by 2 ln of 2. So your correct option is option number C. So your correct option for this question is option number C. Let us move on to your next question. This is a very interesting question, and this is asking you to find the area under this region. So first let us see what this fx looks like. This is maximum of this particular function, and n is ranging from 1 to 10. So let us see how this function behaves. So let us calculate at n is equal to 1. At n is equal to 1, my fx will be, my fx is nothing but, this is 1, so this becomes 1 minus mod of x minus 3. And let us see at n is equals to 2 as well. So my fx will be 2 into 1 minus mod x minus 5. So this is my function. Let us see how its graphs look like. So when you will plot it, when you will plot this for n is equal to 1, this is 1 minus mod of x minus 3. So this will be 0 at 2 and 0 at 4. Put value 0, put value 2. You will get mod of 1, minus 1, 1 minus 1, 0, and at 4 it will be 0. Where it will reach its highest value can be 1, which will be at when x is 3. So this looks like the graph of this function is a triangle. The graph of this fx is a triangle, and triangle with a height. The height of this triangle is 1 units. Now similarly, let us plot this. So this will be 0 at 4, and next value at which it will be 0 will be 6. So the graph looks like this. This is again a triangle, and triangle with a height 2, because when you put 5 it will be 0, 2 into 1, 2. So this is a triangle again which is having value 0 at 4 and 6, and this is a height 2. Similarly, when you will draw other functions for n is equal to 3, 4, you will find triangles. You will find triangles with more heights, and this will keep on going. So this will be a triangle of height 6, triangle of height 3, and this will be from 6 to 8. So if you want to look at this function, this is how this function look like. 1 minus mod of x minus 3 is this. Then your next 2 into 1 minus mod of x minus 5 will look like this, and so on. This function will keep on going. This is with a height 2, this is with a height 3, the next triangle is with a height 4, and base is always 2. And I want its maximum. So you see, for the maximum, this is what, till here, this function is giving me maximum. In next, this is the max. In next, this is the max, and so on. So I want area of these triangles till value n is equal to 10. So I only need to calculate the area of triangle till 10. So what I need area of triangles, and what it will be, half into base into height. So base of all these triangles are 2. So half into 2. Height of this is 1, then 2, then 3. So 1 plus 2 plus 3, and this will go till what value? Till 10 plus 10. So 2 and 2 cancels out. This is sum of n terms, n plus 1 by 2. So this will become 55. So the answer to this question is 55. So the area of this particular region comes out to be 55 unit. Now your next question, what it says, largest area of a rectangle whose sides are parallel to the coordinate axis, and that can be inscribed under the graph of, this is e to the power minus mod x. E to the power minus mod x, and above the x-axis. So if you know, the graph of e to the power mod x minus mod x is somewhat like this. So this is the graph of e to the power minus mod x. Now I want a rectangle inscribed under this and above the x-axis. So my triangle would be something, my rectangle would be somewhat like this. So this would be the rectangle. Let us say its coordinates are alpha, comma 0, and here minus alpha, comma 0. It will be symmetric around the axis. So minus alpha, comma 0 and alpha, comma 0. Now this is the point at which it touches the graph. So the coordinates of this point will be, alpha, comma e to the power minus mod alpha. And here minus alpha e to the power minus mod alpha. Right? Mod of minus alpha. That would it be. Right? Now I want the area of maximum triangle. I want maximum area. So area of rectangle formula for area of rectangle, this is length into breadth. So the length, so from here to here you can see length is 2 alpha, and height you can see this is what it moves in this particular portion, so that is e to the power minus mod alpha. And since we have assumed alpha to be greater than 0, since alpha is on the positive x-axis, we have assumed it to be positive, so this will become e to the power minus alpha. Mod will come out and it will become e to the power minus alpha. So this is area of rectangle. So this is a function of alpha. All you need to do is just, so a alpha is equal to 2 alpha e to the power minus alpha. Now you want to find the largest area, just take the derivative and solve. So a dash alpha will be 2 alpha e to the power minus alpha into minus 1 plus 2 e to the power minus alpha. Applying the product rule, so then you can take 2 e to the power minus alpha common, and this will become 1 minus alpha. From here 1 and from here minus alpha, and put it equal to 0. Now e to the power minus alpha is never 0. This term is never 0. This term is non-zero. So only thing is 1 minus alpha has to be 0. So alpha is equal to 1. So my alpha comes out to be 1. So this is the only point at which I can find the minima or maxima. Now check, if around 1 it is a minima or maxima. So this is your alpha as 1, this is your somewhere 0, and there will be some point around 1. So to the left of 1, when you put any number less than 1, this will be less than 0. Sorry, this will be greater than 0. This will be greater than 0. You put any number less than 1 in this, so it will be positive, this will be positive. So derivative is positive here and derivative is negative here. So derivative changes sign from positive to negative, which means your function looks like this. So I know at 1 it has its maximum. So this is the point of maxima. So this is your point of maxima, and you want to find the maximum area. So just put the value of alpha 1 here. So we'll get a of 1 as 2 into 1 into e to the power minus 1, that is 2 upon e. So your maximum area is 2 by e, which is your option number D. So this is your next question. It tests your integration as well. It will also test your differential equations, and also it is asking you to calculate the mean. So this is a mixed concept question, and let's see how we will approach this. So first you take derivative on both the sides. So differentiate both the sides. So you'll apply the chain rule here. So this will become 2fx f dash x is equal to derivative of 25 is 0, and we know the integral derivative when it is a variable. This will become fx square plus f dash x whole square. So take it to the right. What we will get? We will get fx square plus f dash x square minus 2 fx f dash x is equal to 0. Now this is nothing but this is fx plus, sorry, this is fx minus f dash x whole square is equal to 0. Now square cannot be 0, so the term has to be 0. This means fx is equal to f dash x. And from differential equation we know solution of this comes out to be fx is of the form some c e to the power x. So this is of the form some c e to the power x. Now I want to know what this constant c is. I want to know the value of this constant c. So how we can approach that? I want the value of this c, how we can approach that value. So when you put x is equal to 0 here, this will be integration from 0 to 0. And I know integral from 0 to 0 or from a to a is always 0. So put x is equal to 0 in this. So you will get f of 0 square will come out to be 25. So now f of 0 becomes plus minus 5. So your value of f0 will be plus minus 5. Now it also says this is a non-negative function. So we will only take plus 5. So my fx is 5 e to the power x. Now I want mean of this particular value. So mean is what? Mean will be summation from k is equal to 1 till what term? 625. This is f of ln of k divided by 625. This is your mean. This will be your mean. So let us see what f of ln of k looks like. F of ln k. So let us find f of ln of k. This will be 5 e to the power ln k. E and ln cancels out. This becomes f of ln k will be 5k. So this is 5k upon 625. So I'll sum it from 5k. So this is nothing but summation k is equal to 1 to 625, 5k upon 625. Now 5 is a common number, it is a constant, and sum of first k terms, and this is from 625. So this will be what? This will be 5 and 1 to 625. So that will be n into n plus 1 whole divided by 625. 5 was a common term. 1 plus 2 till 625, n upon n plus 1 into 2. So you'll get a 2 also in your denominator. So 6 to 5 cancels out. This gives me 131, and 131 into 5 will be, this will come out to be, sorry, this will be 100, this will be 313, not 131, this will be 313. So 313 into 5 comes out to be 1565. So we are dividing it by 2, right? So this will be 313. So 313 into 5 will be 1565. So your correct option is option number A. Now this is your next question, and this is from your differential equation. So let us look at it and solve it step by step. So you can see a term with multiplied with y dash. So divide it by that term first. So this becomes y dash minus 2x upon x square minus 4 into y plus 2x. Now this is a square. I can also write this as x square minus 4 whole square divide by x square minus 4 is equal to 0. I can take a negative common. I can write this as x square minus 4, and minus cancels out. So this is how I can write this. Now next step, this becomes y dash minus 2x upon x square minus y into 4. Now one term cancels out. This becomes 2x upon x square minus 4 is equal to 0. So put it to the right. Send it to the right. This will be y dash minus 2x upon x square minus 4 into y is equal to minus 2x upon x square minus 4. This is what you will get as your differential equation. So this is of the form y dash plus px into y is equal to qx. So this is a linear differential equation. So let us find its integrating factor. So the integrating factor is e to the power integration of minus 2x upon x square minus 4 dx. When you integrate this, take this as u, you will find 2x dx as your du. So this will be finally minus ln of x square minus 4. Now take negative inside. So this will come out to be 1 upon x square minus 4. So your integrating factor is 1 upon x square minus 4. So now solve. What is the solution? Y into integrating factor. So y upon x square minus 4 is equal to integration of qx into integrating factor. So minus 2x upon x square minus 4 into, sorry, this was in multiplication, right? Here this was in multiplication with 2x. So this is power 1, and here it was a power 2. So when you cancel it, this will be in multiplication with 2x. So this will be minus 2x into x square minus 4. So that will be in multiplication there, right? That was a mistake. I just cancelled and did not put it there. So right, you don't have to make that kind of mistake. So this was minus this. So this and this cancels out. So this becomes y upon x square minus 4. Now integration of this will be minus x square plus a constant c. So what your finally y comes out to be? Your finally y becomes, y is x square minus 4 into c minus x square. Now I want the value of this constant. So I am given a point where it passes through. So just substitute it here. Substitute the point here. What you will get? When you will substitute it, this is 15. This will be 3 square, which is 9 minus 4. 5 into c minus 9. So 5 and 15 cancels out. This gives me 3. And now when you added this 9 to the right, you will get c is equal to 15. So your value of constant is 15. So your value of constant is 15. So ultimately my y is x square minus 4 and 12 minus x square. So this is what my function is. Now you want its local maximum. So for the local maximum, we do the derivative again. So now the derivative y dash will be 2x 12 minus x square plus x square minus 4, and derivative of this will be minus 2x. Take 2x common, this will be 12 minus x square, and from here you will get minus x square plus 4. So this will be 2x 16 minus 2x square. Now take 2 also common, so this will become 4x 8 minus x square. Now put it equal to 0. For the local maximum and minima, we put it equal to 0. What I'll find? I'll get 3 points. I'll get from here x is equal to 0 plus minus 2 root 2. So I get 0 plus minus 2 root 2. So how it will look like? So this is 0, this is 2 root 2, and this is minus 2 root 2. Now in question it says x is greater than 2. So I only want to check its value at 2 root 2. How the functions behave around 2 root 2. So check how the functions behave around 2 root 2. So check its slope. So towards the left of 2 root 2. Towards the left of 2 root 2, this will be positive, positive. So overall it will be positive here and derivative will be negative here. So function is increasing first, then decreasing. So I know at 2 root 2 I have the maximum. And what is its maximum value? So for the maximum value, substitute 2 root 2 in your function. So substitute 2 root 2 in your function. What you will get? When you will put 2 root 2, so that square of 2 root 2 is? Square of 2 root 2 is 8. So square of 2 root 2 is your 8. So this will be 8 minus 4 into 12 minus 8. So this is 4 into 4, that is 16. So your answer is option number B. So the local maximum value of this function is 16 and at the point 2 root 2. Next question. So what it says? Function is defined from 1 to infinity going to 2 to infinity. And this is given to be a differentiable function. I want to find the value of function at point 3. Again, you can see an integration with a variable. So first thing that comes to your mind, that should come to your mind is differentiated. So this will become 10 fx, and on the right side you apply the product rule. This will be 5x f dash x plus 5 fx minus, this is what? This is x to the power 5. So this becomes minus 5x to the power 4. Now this is 10 fx, this is 5 fx. So I can put fx as y. So let us solve it by taking it to be y. That would be easy. This is y dash plus 5y minus 5x to the power 4. Because we are more used to solving it using y. So I'm just taking it as y. Now this is 10y, this is 5y. This becomes 5x y dash minus 5y is equal to 5x to the power 4. This to the left, this to the right, this becomes minus 5y, and this to the left, this becomes 5x to the power 4. So now divided by 5, we can take common and cancel out. So this will be xy dash minus y is equal to x to the power 4. Now divide by x. So this will be y dash and this will become x cube. This will become x cube. Now again, this is a linear differential equation. Integrating factor e to the power integration of minus 1 by x dx. That will give you e to the power minus ln x, and this will be 1 by x. So your integrating factor is 1 by x. Now again, the solution is y into integrating factor is equal to integration of qx into integrating factor plus a constant. So y by x, and this will be square. When you integrate it, this will become x cube by 3 plus c. Now substitute this x to the right. This becomes y is equal to x to the power 4 by 3 plus c. This is what I get as my answer. Now I want its value at 3. I don't know what is the value of this constant. Again, when you put x as 1, the integral will be 0. So put x as 1. Put x as 1. So this will be 0. This will become this will become 5 into 1 into f1 minus this is 1 minus 9. So 5f1 will come out to be 10, which implies your f1 is 2. So you know value at 1 which is 2. So you know value at 1 which is 2. So substitute it here. 2 is equal to 1 by 3 plus c. So this will give you c as 2 minus 1 by 3, 5 by 3. So this will give you c as 5 by 3. So what your y becomes? So your y is nothing but, your y is now x to the power 4 upon 3 plus 5 by 3. Now I want its value at 3. So just put x is equal to 3. So y at 3 will be 3 to the power 4 upon 3 plus 5 by 3. So this will be 27. Okay, sorry, I did not multiply x here. I forgot to multiply this x, but I'll take this to the right. So this will be, so what the value of x I put? It was 1 only, so this will be 1 here. C will come out to be 5 by 3 only. But here was a x also, so you will put 3 here. Here it was a x also, so you'll put 3 there. What you will get? 3 cancels out. 27 plus 5. This will be 32. So the answer to this question is option number B, 32. You multiply x there, so you'll multiply it with x as well, right? You'll multiply it with c as well. So let us look at your next question. This is a IAT PYQ question and this is a very good conceptual question. But this will go a little lengthy, so we need to follow it step by step. What it says, Ri denote the sum of ith row, Cj denote the sum of all entries in jth column. Now we are asked to find how many 3 cross 3 matrices with non-negative integer entries. This is an important thing to note down, non-negative integer entries, such that this condition and this condition are satisfied. So let matrix be A, B, C, D, E, F, G, H, I. So you let 3 cross 3 matrix be A, B, C, D, E, F, G, H, I. Now according to the conditions or according to the constraints, you are given R1 is equal to R2 is equal to C1 is equals to C2 is equals to 2. So for this condition, R1 is equal to R2 is equal to C1 is equal to C2 is equal to 2. What you will get? Sum of row 1, this sum, A plus B plus C. So A plus B plus C is equal to 2. Next, D plus E plus F is equal to 2. Then first column, so that is what? A plus D plus G. A plus D plus G is equal to 2. And second column, that is your B plus E plus H. B plus E plus H is equal to 2. This is a condition on your rows and columns, first and second. This condition, R3 is equal to C3 is equal to 1. So from here I'll get C plus F plus I is equal to 1 and G plus H plus I is equal to 1. Now here you will make cases. See, I is common in both. So we will make cases on I and that will be easy for us. So we will make cases on I when I is equal to 1. So since the entries can be non-negative integers only, so I can be either 0 or 1. If it is 2, then the sum cannot be equal to 1. So it is either 1 or 0. So let us solve first case, I is equal to 1. When you put I is equal to 1, directly your C, F, G, H becomes 0. This gives C is equal to G is equal to F is equal to H is equal to 0. So these directly become 0 because I is 1. So sum will become 0, 0 and these are non-negative integer entries. So all C, G, F, H has to be equal to 0. So this is what I get. Now use this condition and make cases on these conditions. So when your C is 0, what I'll get? So I'll get A plus B is equal to 2, G is 0, which means A plus D is equal to 2, and F is also 0, so I'll get D plus E is equal to 2, A plus D is equal to 2, and lastly B plus C is also is equal to 2. So this is what I get when I made this case. So this gives me more cases. Now values of A, B, D, E. These values can also be only non-negative integer entries. So let us make more cases from here on A. We can take any case on A, B or D. So let us put cases on A. First, A is equals to 0. I can take A as 0, 1 or 2 because the maximum sum is 2. So when A is 0, that directly gives me B is equal to 2. When A is 0, B is 2. This implies if B is 2, E is 0. If E is 0, D is directly 2. So from here, I'll be able to construct one matrix for these particular values. So one matrix from here. So this gives me one matrix. Now next case. Next case is when, let me write it here now. Next case when A is equal to 1. This was the case when A is equals to 0. When A is 1 now. When A is 1, B has to be 1. If A is 1, B has to be 1. If B is 1, E has to be 1. And if E is 1, D has to be 1. So this is your second case and this is your second matrix that you will follow when you take A is equal to 1. Thirdly, last value of A that you can take is A is equal to 2. When you take A 2, B will be 0. This gives B 0. If B is 0, E is 2. And if E is 2, then D has to be 0. So I got one matrix here, one here and one here. So for this case, when I was 1, I get 3 matrices. Now when I is 0, so this is the case when I is 0. I can be 0 or 1. So this is the case when I is 0. So when I is 0, I'll get 4 separate cases. I'll get 4 separate cases on CFGH. So for this, first I'll make cases on this and then I'll move to the cases on AB, D and E. So if this is 0, first if C is 0, F is 1. C is 0, F is 1. And G is 0, H is 1. This is the first case. Next, C is 0, F is 1, G is 1, H is 0. This can be the second case. Third case, C1, F0, G0, H1. And the last case will be C equals to 1, F is equal to 0, G is equal to 1, H is equal to 0. These are the 4 cases that will be formed when I is equal to 0. So these are the 4 cases. Now put these cases in this particular values. So from here what you will get? From here what you will get? C is 0. C is 0, so A plus B is equals to 2. A plus B is equals to 2 and F is 1. So D plus E is equals to 1. D plus E is equal to 1. G is 0. So this will be A plus D is equals to 2. A plus D will be equal to 2. And H is 1, so B plus C will be equal to 1. Now solve this again. Take values of A, B, D we want. So again make cases for A and A. So I'm just solving for this particular case. For rest of the cases, you will do it as a homework. I am solving it for this particular case. And let us do this here. Let us see this. Let us see this here. Right? Because I don't see any space, so I'll just do it here. So when A is 0, when I put A as 0, I'll get B is equals to 2. When I put A 0, I'll get B as 2. And if B is 2, E will be minus 1. So this implies E is equals to minus 1. So this case is not possible because these are non-negative integer entries. So this case is discarded. Next, A is equals to 1. When A is 1, B is 1. If B is 1, E is 0. If E is 0, then D has to be 1. If E is 0, D has to be 1. So this is a valid matrix. All entries are non-negative integer entries. Next, A is equals to 2. When A is equals to 2, A is equals to 2 implies B is equals to 0. If B is 0, E will be 1. And if E is 1, D will be 0. So this is again a valid matrix. So from this case, I get this, and this gives me ultimately two matrices. So this case gives me two matrices. Now similarly make cases for these, and you will find two matrices here. You will find two matrices here, and you will find two matrices here. So total matrices are 3 plus 2 plus 2 plus 2 plus 2. So these are total 11 matrices. So the correct answer to this question is 11 matrices. So I hope you will be able to do this. This is a very easy step. All you need to do is just make these cases and solve for this. Let's come to your next question. So this says P be a 3 cross 3 matrix with real entries, and the condition is P square is equals to minus P. And then we have to comment on P, what P will be. So whenever you see these types of options, the best way to approach is take a particular matrix P and discard the options. So if I take P as minus 1, 1, 0, 0, 0, 0, 0, 0, 0, and also a suggestion to you, try to make such a matrix that most of its elements or entries are 0, because that is easy to calculate and that is easy to solve. So this is your P. When you calculate P square, so if you calculate P square, so that will be 1 minus 1, 0, 0, 0, 0, 0, 0, 0. So when you calculate P square, this is what you will get. Now this is nothing but this is equals to minus of minus 1, 1, 0, 0, 0, 0, 0, 0, 0. So this is nothing but minus P. So my condition that is given in question is satisfied. So this is a valid matrix that will satisfy this condition. Now check, are the options correct for this? Is this a diagonal matrix? No, A is incorrect. Sum of diagonal entries is 0 or minus 3. So the sum of diagonal entries, that is minus 1. So this is also an incorrect option. Now option number D says if P inverse does not exist, then P to the power k is 0 for some natural number k. So for this, let us consider another example, a more easy example. Let P be minus 1, 0, 0, 0, 0, 0, 0, 0, 0. When you calculate P square, it will again come out to be equals to minus P. When you calculate P square, what it will be? P square will be, your P square will be 1, 0, 0, 0, 0, 0, 0, 0, 0. Now calculate the higher powers, P to the power 3. So P to the power 3 will come out to be again P. If you calculate P to the power 3, it will be P. Then P to the power 4 will again come out to be equal to minus P, and so on. So this is never equals to 0. P inverse does not exist. In this case, P inverse does not exist, right? But still, I cannot get any natural number k for which this is equal to 0. So my option number D is also incorrect. Now what option number C says? If P inverse exists, then P inverse square is equals to minus P inverse. So if P inverse exists, I can multiply P inverse on both sides. So this will be P inverse into P square minus P into P inverse. This gives me P is equals to minus identity matrix. P into P inverse is what? Identity matrix. So if P inverse exists, P is my minus of identity matrix. So what will be the inverse of this? So P inverse will be your identity matrix. P inverse will be your minus of identity only. If your P is minus of identity, P inverse will also be minus identity matrix. So P inverse square. So square of this is identity. And what is minus of P inverse? So this was your P inverse. And minus of P inverse is also identity. So this is a correct option. So option number C is your correct answer. Now next question is also from your matrices, and this tests your knowledge of cofactors of a matrix. So this wants the cofactor of matrices. So this is the cofactor matrix for this. This is saying this is the matrix of cofactors. So let us calculate cofactor of this entry. So what will be the cofactor? That will be 2 alpha square minus, cofactor of this will be 2 alpha square minus alpha into beta. And since the cofactor is this, but this is said to be the cofactor matrix, so this has to be equal to 3 alpha. Now let us evaluate the cofactor of this element. So we'll get a negative sign because this is the odd power. So negative cofactor will be 2 alpha square minus 3 alpha. And here the cofactor is minus alpha. So alpha alpha cancels out. Solve this. This is a quadratic in alpha. You can easily solve this. So when you solve this, what you will get? 2 alpha square minus 3 alpha is equal to alpha. This implies 2 alpha square minus 4 alpha is equals to 0. Take 2 alpha common, you will get alpha minus 2 is equals to 0. So from here you will get value of alpha as 0 or 2. So value of alpha is 0 or 2. Now since in the question you are given the information alpha beta cannot be equals to 0. If you multiply alpha beta, it cannot be equal to 0. So alpha cannot be 0. So from here alpha is non-zero, beta is non-zero. So the only valid is alpha is equals to 2. So my value is alpha is equals to 2. Now put it in this equation and find your beta. So this will become 8 minus 2 beta is equals to 6. So 2 is equals to 2 beta. So your value of beta is 1. So now you know alpha and beta, you can easily see what your matrix A is. So what will be your matrix A? The matrix A becomes 1, 2, 3, 2, 2, 1, minus 1, 2 and 4. This is your matrix A. Now you want determinant of A into B. So we know determinant of AB is determinant of A into determinant of B. Right? This is the determinant. And B is what? B is the matrix of cofactor. So B is cofactor of A. Right? When you take transpose, when you take the transpose, B transpose will become what? B transpose will become adjoint of A. I know if the transpose I take of cofactor matrix, it becomes the adjoint of that matrix. Now I know determinant of B is equals to determinant of B transpose. So the determinant of this matrix or the transpose will be same. So I take the determinant in this. So you take determinant here. Determinant of B transpose will be determinant of adjoint of A. And what is the determinant of adjoint of A? Determinant of A to the power n minus 1, where n is the order of this matrix, which is 3. So this is nothing but determinant of A square. So what I need to evaluate is, I need to evaluate determinant of A into determinant of A square. So this is nothing but determinant of A cube. So finally I want determinant of A cube. So this is your matrix A, find its determinant and cube it. So what will be the determinant of A? So 1, 8 minus 2. Minus 2, 8 plus 1. And then plus 3, 4 plus 2. So that will be the determinant of this matrix. This will be 6 minus 18 and this will be 6 plus 3, 18. 18 cancels out. So determinant of A is 6 What will be the determinant of cube? That will be 6 cube. This implies you want 6 cube, that is 216. So the answer to this question is 216. So all you need to do is just equate the cofactors in each entries. So your next question is from vectors, and let us see how we will do this question. So you are asked to find the value of determinant of A into D. Now, what is the information that you have? You have A vector and B vector, and it is given A minus C into B is equals to this. Now, make this as 13, right? So, there was a misprint here. This is 13 here. So, take this as 13. And A dot C is given to be 3, and B cross C is given to be as D. So, when you know B cross C is D, I can say this is nothing but A into B cross C. So this is same as this because B cross C vector is D vector. So I want the value of the determinant of this particular value. Now I can see I have B cross C term I can get from here. When you expand that, what you will get? You will get A vector cross B vector minus C vector cross B vector. And that is given you to be equals to, that is given us to be equal to minus 18 I cap minus 13 j cap plus 12 k cap. This is what this is given to us. So when you do this, now cross product can be reciprocated with a negative sign. So this becomes B vector cross C vector. We can switch the sign, we can switch the sides by taking a negative sign. So negative, negative, positive. So this is minus 18 I cap plus 12 k cap. Now all we need to calculate is A cross B. We want B cross C. So I'll calculate A cross B. I have A vector and B vector. So let's calculate A cross B. So what will be your A vector cross B vector? So this is I cap, J cap, K cap. What is your A vector? 2, minus 3, 1, and this is 3, 2 and 5. Find the vector. This is I cap minus 15 minus 2, minus 17. Minus k cap, this will be 10 minus 3, 7. Plus, sorry, this will be j cap. This is j component. This is your j component, that is 7, and then your k component. So what is your k component? That is 4. 4 plus 9, 13. So this is your I, j and k. That is your I, j and k components. So this is your A cross B. So you have A cross B now. So what will be your B cross C? So your B cross C vector will be, you will subtract it by taking to that side. So you'll get minus I cap. When you subtract this from this, minus I cap, this becomes minus 6 J cap, and this becomes minus K cap. So this is your B cross C, which is nothing but your D vector. This is nothing but your D vector. So I want A dot D. I want A dot D. So I want A vector dot D vector modulus. So what will be the dot product of this? What will be your A dot D? What will be the dot product of A and D? The dot product of A and D. What is your A vector? A vector was this. So dot product it. 2 into minus 1. Minus. This is minus 3. So this is plus minus 3 and minus 6. And this is 1 and this is also. So plus 1 into minus 1. That will be your dot product, and we will take its mod value, which means positive value. So this will be minus 2 plus 18 minus 1. So this comes out to be 15, which is already a positive value. So the answer to this question is 15. So 15 is your correct answer. Next question is your concept from your 3D. So this is the, consider a line L which passes through this and this point. The distance of this point we have to evaluate from the line L. We have to evaluate the distance of this point from L along the line. So what along the line means, which means it should be parallel, it should be parallel to it. So let me tell you how we'll solve this. So this is your line passing through 1, 2, 3 and 2, 3, 5. So these are, let's say, your point 1, 2, 3. This is your point 2, 3, 5. I want distance of the point 11 by 3, 11 by 3 and 19 by 3. Let's say this is your point 11 by 3, 11 by 3 and 19 by 3. I want distance of this point from this line. So I need a point on this line. I need a point, let's say Q, and let's say this is P. Now what does along the line means? Along the line means when you join these, when you join this and form a vector, this will be parallel to this line. So this has to be parallel to, let's say, whatever this line is. So this vector will be parallel to this. That is what along the line means. So we want the equation of this parallel to this. So let us see how we will find it. So we are given 2 points on this line. What will be its direction ratios? Direction ratios will be 2. Direction ratios for this will be 2 minus 1, 1, 1 and 2. Direction ratio for this line is 1, 1 and 2. So any general point on this line will look like, how I can represent this line as, I can write this as x minus 1 upon 1, y minus 2 upon 1 is equals to z minus 3 upon 2 is equals to some lambda or some constant k. So any general point on this line looks like lambda plus 1, lambda plus 2 and 2 lambda plus 3. So the coordinate of this, let's say lambda plus 1, lambda plus 2 and 2 lambda plus 3. So any general coordinate can be written as x is equals to lambda plus 1, y is equals to lambda plus 2 and z will be equals to 2 lambda plus 3. So that is any general point on this line. So now I have this vector, I have this point coordinates, I have the coordinate of this point. Now what I want is direction ratio, something about its direction ratio. So we will see the direction ratio of this line. The direction ratios of this line. First write it in its standard form. So this will be x minus 11 upon 11 by 3 upon 2 by 3. This will be y minus 11 by 3 upon 1 by 3 and that will be z minus 19 by 3 upon 2 by 3. So the direction ratios are 2 by 3, 1 by 3 and 2 by 3. What you can make mistake here is you don't write it in its standard form. So direction ratios are from here. Your direction ratios are 2 by 3, 1 by 3 and 2 by 3. Now I can take 1 by 3 common. That is a multiple. So direction ratios can be simplified as 2, 1, 2. So by chance their direction ratios are same, 2, 1, 2. But that is not the case every time. So you have to make sure you convert it in its standard form first. So this is what the direction ratios are. So for this line, direction ratios are 2, 1, 2. Now I know if this is parallel to this, direction ratios will be in proportion. So direction ratios for these two will be in proportion. So what I can say? I can say direction ratio of this will be in proportion to direction ratio of this. So direction ratio of this will be lambda plus 1 minus 11 by 3. For this it will be lambda plus 2 minus 11 by 3. For this it will be 2 lambda plus 3 minus 19 by 3. And these are in proportion with 2 comma 1 comma 2. So when you compare them, what you will get? If these are in same proportion, you will get lambda and this will be minus 8 by 3 upon 2. This has to be equal to lambda. This will be minus 5 by 3 if you solve this and if you solve this. It will be equal to 1. So from here, let's solve lambda. What will be your value of lambda? Let's solve that. So this will be lambda minus 8 by 3 will come out to be equal to 2 lambda minus 10 by 3. Now substitute and solve. So we will get 2 lambda minus lambda is equal to 10 by 3 minus 8 by 3. So value of lambda comes out to be 2 by 3. So the value of your lambda is 2 by 3. So this lambda value is 2 by 3. When I know this value, I can directly find the distance of this point from this point by applying the direction distance formula. By applying the distance formula. So I know my lambda. So this point will be 2 by 3 plus 1, 2 by 3 plus 2, 2 into 2 by 3 plus 3. Or I can directly solve this part. This is this minus this. So what will be its distance? Let's find this point Q. So your Q point is lambda plus 1, 2 by 3 plus 1. That will be 5 by 3. Next point, lambda plus 2, 2 by 3 plus 2, 8 by 3. And then 2 lambda plus 3, 2 into lambda. That will be 4 by 3, 4 by 3 plus 3. That will be 13 by 3. So these are your coordinates of Q, and you know your coordinates of P. Just apply the distance formula. So we want distance, so P, Q. We want the distance, that will be under root 11 by 3 minus 5 by 3 whole square plus next point is 11 by 3 again. So 11 by 3 minus 8 by 3 square plus this is in this only. Next point is 19 by 3 minus 13 by 3 whole square. So what you will get from here? From here I get 6 by 3. This will be 6 by 3 which is 2. 2 square is 4. So this will give me under root 4. This will be 3 upon 3, 1. 1 square is 1 plus 6 by 3, 2. 2 square is 4. 4 plus 4, 8 plus 1, 9 and root of 9 is 3. So your final answer is 3. So the distance of any point on this line to this is 3 along this line. So the answer to this question is 3 units. So let us see and do our last and final question of this series. So you are asked to tell how many solutions does this equation have in this particular interval. Now you have two ways to approach this question. Either you will solve it by taking it to the left and do the algebraic calculation, but that will go very lengthy and you don't have to do that. The trick here is you have to just draw the graph of tan 2x and cos x by 2 in this particular interval and check where these two graphs will intersect. That is the concept and trick that you will use in this question. Now I know the period of 10x is my period of 10x is what? Pi. So the period of this will be pi. Period of 10x is 2 pi. So period of this will be pi. So when I draw this in this particular interval, this is your, let's say, point 0. When will your tan 2x be 0? It will be 0 at point where it is taking values equal to sine. So it will be 0 at 0. The next point it will be 0 at pi by 2. So this is, let's say, your pi by 2. Next it will be 0 at pi. Then 3 pi by 2. And then next at directly 2 pi. So when you draw the graph of this, now see when does the definition or periodicity of this changes. So this is your point pi by 4. This is your point 3 pi by 4. This is 5 pi by 4. And next point is somewhere 7 pi by 4. When you want to draw the graph of tan 2x, put the value pi by 4. This will give you pi by 2 and I know at pi by 2 this goes to infinity. So your graph blows like this. So your graph goes like this and then it changes its definition and it will go from, and it will go like this. It will be 0 at pi by 4. It will be 0 at pi by 2, sorry. It will be 0 at pi by 2. You put pi by 2, you will get the value of tan 2x at 0. So this will go like this. In next, it will be like this. In your next region, your 10x will be like this. So this is how your 10x graphs looks like in this interval 0 to 2 pi. And next, it will be somewhat like this. So let's say this is your point 2 pi here. So this is your point 2 pi and it will meet the point 2 pi. So this is the graph of tan of 2x in this interval 0 to 2 pi. You can check it and draw it on your own by putting some particular points and values. You will find these are the vertical asymptotes that you will find for this graph. And next we want to draw cos of x by 2. Next we want cos of x by 2. Now put values and check. If you put pi by 2, it will be pi by 4 and cos of pi by 4 will be somewhere here. So at 0 it will be 1. At 0 it will be 1. It will take value 0 at pi because cos of pi by 2 is what? 0. When you put it pi, then it will be pi by 2. So cos x graphs moves like this. So its period changes from 2 pi to 4 pi. Its period now changes from 2 pi to 4 pi. When you put 2 pi here, you will get 2 pi by 2. 2 cancels out, you will get cos of pi and cos of pi is minus 1. So this is what graph of cos of x by 2 will look like. Now just find the point where they are meeting. So this 1, 2, 3, 4 and 5. These are the 5 points where the graph of tan of 2x and cos of x by 2 meets. So we have exactly 5 points in the intersection. So this is the answer to your question. The graph drawing may be a hectic process, but this is the easiest way you can approach these types of questions. So I hope you understood all the questions and you are preparing well for your exams. So I hope you all the best and I wish you all the good luck and do your best in your exams and let us see you in your dream institute.